Hello grade 12s, welcome to my channel. Let us have a look at probability. Right, so we're going to be focusing on this component of what we have right here, the probability part. And this is mainly the grade 11 work, but grade 12 needs to also incorporate this because it is examinable in grade 12. Now folks, as you can see, this document was in some workshop last year, KZN and all, and you can see it's the answer series group that was involved here. I did not compile this, so I don't know if there's going to be any trouble for using this, but I got this document off the internet for free, so I would suppose there shouldn't be any issues. But what I liked is that as I skimmed through this, I saw that the questions kind of build a student from basics to somewhat advanced questions, so which I think would be proper for us to essentially do this course using this document. The document is actually free, guys, so you can download it on the internet somewhere, but I may have to find out if I can perhaps share this document with you. But I will certainly share my, should we say, the memo section and some notes with you guys. It's going to be on the description below. And please, folks, do your best. Don't expect miracles. Let it be something that finds you on the way rather. Great, guys. So what do we mean when we talk probability? What is it? Probability. Okay, I already wrote this wrong. In fact, let's not even say what does it mean. Probability. It's more like the chance of something happening. Rather, what's the probability of this occurring or not occurring? So it's more like what are the chances, but it's more like of a quantification of a chance. I would put it that way. That's what probability is. So we just quantify a chance of something occurring or not occurring. So that's in essence the probability. So we just put numbers to it, rather than to just guess that it's more likely, it's unlikely. Can you see that's vague? We cannot put numbers to that. But of course, if I say something is very likely, you would almost expect something above 60% to 80%, and perhaps 90%-ish towards 100%. When I say very likely, we know that it has a very high chance of happening, so we can almost guess. But remember, at this point, we're looking at a bracket of possibilities rather than a specific number. But in this case, we actually give an exact number, or at least the closest number possible. Right, so that's probability, guys. Let's not explain the word, but you should already know. So sitting amathuba. Angakanani amathuba woba into ethile yenzeke okanye ingenzeki. Yayiqonda? So ndelolo hlobo. Now, that's what we know. Okay, guys. So probabilities, if I can give you notes, we should know stuff that there is actually 3 rules here. Maybe 3 tools to master. First, we need to master 3 tools in probability, meaning we know how to handle those tools, sometimes how to even come up with them for a given question, so that we can answer questions adequately, at the same time fully representing a given scenario on those tools. So the first one is a Venn diagram. All right, a Venn diagram is a very useful tool, folks. If I can recall, I think I was taught how to use a Venn diagram either in grade 2, that's if I'm not silly now, or grade 5, which is standard 3. I'm not too sure which one of the two. The only reason I'm not so sure is because the person who taught me grade 1, which is sub A, as well as sub B, is the very same person who taught me standard 3 and 4, okay, which is grade 5 and 6. So now I get a bit of a situation trying to remember exactly, but sets, we spoke about sets as early as grade 2. And this intersection business was there. We were literally studying numbers, natural, prime numbers, and all those things. So, so we were taught properly, guys, unfortunately. I don't know about you folks, but yeah, what I see, it's horrible. Anyway, a Venn diagram. So we need to know how to construct a Venn diagram and essentially how to use it, and when would we perhaps think of using it. At this point, we'll just restrict ourselves to exactly when would we choose it. We can simply say when we've got perhaps 2 or more events. Okay, 2 or more events. Okay, so usually this is what happens. So we can use a Venn diagram under these circumstances. Okay, now let's leave that for now. So the next tool that we need to master is a tree diagram. Right. Now, a tree diagram is quite useful, and I would suggest we need to master this because it's taught as early as grade 10, I suppose, or even perhaps earlier than that, maybe grade 9, not too sure. But we didn't really do too much of the set theory stuff, and we truly did not do this probability thing per se, although there were questions that kind of involved it, but not to this extent, okay? Because most of this was with us taught higher than matric, especially under the set theory business. So you would know such things at that level, I guess. So the tree diagram as well is for usually 2 or more events. Okay, usually, not always, of course, it could be independent versus not independent. Okay, so this is usually the situation in which we could find ourselves doing a tree diagram. So Venn diagram, tree diagram, you see minimum 2 events, but they can be more. Right, so we need to master this, guys, especially when we are dealing with higher grade questions. Okay, so please note this: for higher grade questions without a warning, you may find yourself essentially needing to know how to construct a tree diagram even when not prompted to do so. So the third tool that we need to master is a two-way contingency table. Okay, now again, two-way tables are taught throughout, think of biology, for example. When you're doing the crosses, you're using a two-way table, isn't it? That's exactly what you do. But again, I don't know how early do you do these crosses. We only did them in first year. But yeah, the idea of a two-way table is important. But here you normally talk of categorical data. Okay, and of course we must have at least 2 categories. Okay, because if we just have one category, I don't think that would be very useful. It can be 2 or more. Sometimes you can have a 2 by 3, 3 by 2, whatever you name it. But as long as we've got at least 2 categories. So categorical data would be more useful to handle with a two-way table. Now remember, these tools, guys, are ways to summarize. So their job is to summarize data. Okay, so they help us to summarize the data so that we can have an understanding of what is going on and how to handle it. So please, folks, know all 3. Now, what is important, folks, know how to construct, I would say. Know how to construct, interpret, and use. Okay, please, folks, this is very important. Know how to construct it, know how to interpret the summarized data there, and also how to use in answering questions. So this is what I would suggest. So if you want to really master this, especially if you're still in grade 11, grade 10, make sure this is your strong point, because I think that's the aim of grade 10, is just to know how to construct these more than, say, you want to interpret a lot out of them. But again, that is not excluded. But by grade 12, you should know how to do all those 3 actions: to construct, to interpret, as well as to use these tools. Okay, let's not sit too much on that. So we've got, again, 3 rules. So I would say probability, guys, it's a 3 tool by 3 rule kind of a situation or topic. This is how I would summarize it. But again, guys, there's a lot to consider. Yes, there are moments where we would have to apply our logic into this. So a whole lot of other things, guys, have a part to play in this. But the basics of it is just 3 rules as well as 3 tools that we need to master. Now, the first rule here is the addition rule. Right. So let's talk about events A and B. So the addition rule suggests that for events A and B, we know that P of A union B, sometimes the union can be substituted with the word or, is going to be equal to the P of A plus the P of B minus P of A intersect B. Sometimes the intersection may be shown with AND. Okay? So please know this, that the word AND means intersection, the word OR means union in maths, essentially. Now, folks, this is the addition rule that we need to know, and we need to make sure we understand. All right. So some students may sit back and be like, why do we have to subtract this intersection? Because this is curiosity at its best, because you would say, okay, I get the rule, but then I know or in maths we can translate with a plus, right? Yes, that's true. And we know from basic classes like grade 8, grade 9, when we say AND, we usually signify multiplication. So again, these are the things that you want to keep in mind, folks, that okay, if I'm talking about an OR in maths, I am thinking addition. If I'm talking about OR, essentially symbolic form, it's a union, right? Then if we're talking about and in maths, then we should be almost thinking multiplication. And of course, symbolically, this is an intersection or intersect type of a symbol. Now the question is, why are we excluding the intersection there, or at least subtracting it? What is happening? Now if we think of a scenario where, let's say we've got our sample space, and in our sample space we've got event A and event B. Right. Now we will notice that we've got an intersection between these two events, which is represented here. All right. So that intersection, we are saying now we're taking it out. Why? Because when we talk A, we mean everything in that set A, okay? So this is mostly for things like set theory. Don't worry about the circles being bigger and smaller. It doesn't really matter at this stage. So when we say probability of A, which is this part right here, we mean everything in set A. Can you see it includes the intersection, which is the yellow part? Then when we say B, we also include everything in that set B. Okay, just a moment. Okay guys, so this is where we are. As you can see, now when we add set A and set B, I mean elements in set A and elements in set B, do you realize that we will capture that intersection twice? And yet, when we talk of a union, what we mean is this. So when we talk of a union, which is this part right here, so we literally mean everything that is in set A as well as in set B. Now this means the intersection can only feature once. Since we doubled it, we then have to take it once, because then it leaves that intersection only once within that union. So that's why we subtract that union, that intersection, because we doubled it in effect. Now we just take it once out so that we avoid that problem. So this is very helpful, guys. Please master the addition rule. It is very important because it is not discriminatory. It fits whatever scenario we would have in those two sets or a combination of. Okay, it's not discriminatory, believe me when I say, but it just fits whatever scenario we may want to create. So it's one of the rules that I would rather, in fact, all of them, let's not even suggest otherwise, all of them need to be understood. Now the second rule that we need to know is the product rule. Okay, now the product rule, again, for events A and B. The product rule is suggesting that the probability of A intersect B is going to be equal to the probability of A times the probability of B. That's the product rule for us. And as we said, the intersection can be replaced with the word and we simply signify some product of some sort. Please remember these. Right. So this is what the product rule says. Okay. Now there's two scenarios that we need to think about. When the left-hand side of our equation is equal to the right-hand side, we say that the events A and B are independent. Okay? So when the left-hand side of that equation of our product rule is equal to the right hand side, we say the events are independent. This is very important to note because it is examinable. Right. But when a situation occurs that the left hand side is not equal to the right hand side, so we say that A and B are not independent. Okay. So obviously when something is not independent, it means it is somewhat dependent. I would put it that way. But that's not necessarily the case always. So we'll not really sit too much on this part. Avoid saying dependent, but rather focus on saying not independent. So this is also suggesting that, folks, a mere intersection between two sets is not indicative of whether they are independent or not. But it's only when the product rule is giving us the left-hand side equaling the right-hand side where we can say the events are independent. And when it's not the case, we just simply say they are not independent, but the intersection exists. I hope this is clear, guys. So I gave you some homework when we were doing the lessons to then check this parameter on all those examples that we worked so that you could see if these things can coexist or they don't coexist. Does the mere presence of an intersection automatically suggest that the events are independent or not? So I know we have done some calculations which I allowed for us to calculate with that assumption because I want this to be very clear. So when I do these summarizing lessons, please watch them even though you did watch or were you perhaps present in the classes. But in the class sometimes I would allow certain things to slide just to make sure that you are clear by the time you come across this thing, because as I put the summary back, you will then start to understand, oh, okay, this is usually the case, this is not the case. So always study things, because it happens that you may think, okay, I've got this topic under my belt or so, and only to find that you actually misunderstood certain things. So this is when we clarify, we clear the weeds now. First we're just planting the seed. Now it started germinating, right? Now it's sprouting up, and as it does so, even the weeds do the same thing. So we want to get the weeds out. This is why I'm doing this video. So please guys watch it, even if you were present in the classes, and you will start to see some of the mistakes I allowed for us to do just to get us moving, at the same time to have you learn when would you say this works, when would you not. Because if you just get told everything at once, it's easy to leave it in the background because you think it's not important. Alright guys, so with the product rule we can get to understand an issue of dependency versus independency. Perhaps dependency not necessarily, but rather not independent versus independent. Okay, so please folks note this thing again, because many students don't answer these questions adequately. All right, so this is perhaps the two things that we need. Okay, the third one, I said 3 ones, so there's a third rule here. This is the complementary event. So okay, let's just say complementary rule. Okay, so the complementary rule, okay, so let's say for example we have event A. For event A and not event A, Sometimes you use A prime there to suggest that it's either we're dealing with A or we're not dealing with A. Now, complementary events rule says that the probability of A plus the probability of not A should be equal to 1. Right. So it means when we add the probability of A happening as well as A not happening, we can have 1. So that's the main rule about complementary events. Okay? Right. So that's the one thing. And of course, there is a condition to complementary rules. So we know that two events are only complementary if the events are mutually exclusive. So A and A prime should be mutually exclusive. Now here comes another term, mutually exclusive. So what do we mean? This means that P of A and not A should be 0. That's the key of mutual exclusivity. We know that the intersection should not happen, meaning you should not have these events occurring at the same time. So that's what we mean when we say these two are mutually exclusive. And this, of course, is also being explained by this scenario right here. That scenario by itself is suggesting the same idea. So this is what we learned, guys. So it means there's no intersection between the two, or the intersection is 0. And then we talk of mutually exclusive events within that complementary situation right there. And of course, this is yet another issue for students to master. Now let's just do this on a Venn diagram just to help a student to know what this is. So let's say this is event A, right? And of course, surrounding that is not A. So this is what we mean by this. Okay guys, so this is the scenario right here. So when you've got event A, which is the white circle, and not A, which is the yellow shaded region, can you see there is no intersection here? They are separate. And that's what we mean by mutually exclusive events. Okay. So this is again something that we need to understand, folks. And yeah, I think that's the story right here. Is there anything missing here? I don't think so. So of course, guys, these are the basic notes that I would give you as a student to ponder upon. Of course, there's more for you to learn, there's more for you to read, but this is essentially what we need to do. And just note that when we say probability of any event E occurring is always equal to the number of ways in which E can be expressed, or in the number of ways in which E presents itself, divided by the number of possible outcomes within the sample space. Right. So please remember that, guys. So yeah, that's the essence of probability. Of course, folks, this is a summary now, which I hope makes sense for those who studied and those who attended classes. Now let's take some questions to sort the issue out nicely. So question 1. Now question 1, guys, is very basic. This could easily be a grade 8, grade 9 type of a question. But the essence of this is to then highlight how probability works, because some of you don't actually understand this. We assume that you do, and in fact you would also think you do have an idea, but perhaps your idea has some flaws in it. Excuse me guys for the background noise. I'm not in my usual place, so I'm in some lodge in Margate due to some serious issues that I had to deal with. So in the meantime, yeah, there may be things I cannot control. Now we are told that there are 20 tickets, right? That's the total number of possibilities in the sample. That's 20 in a hat, and the hat becomes our sample space. Now numbered from 1 to 20. Okay, so each ticket has a number from 1 to 20. Okay, cool. Now these numbers are the elements, isn't it? Or the tickets themselves are the elements of this big set, because we've got a set which is the hat, and this set has a total number of possible outcomes, which is 20 of them, and each individual element is a ticket with a number from 1 to 20. So these are the elements. So we need to know how to, put some sense into these. So this is the set, and the tickets represent elements. Of course, their total number is the total possible outcomes. Now we are told that one ticket is taken out. One ticket is taken out. At this point, it is not clearly stated whether we take it out and return it back into the head, we take it out, or we don't return it into the head, in which case this may spell out certain scenarios or a type of events in a way. Now, the question is for us to determine the probability of taking out. Now, as you can see here, there's no specification when we take this out, we don't return it, or we return it. So in which case it says each individual question is likely to be the first instance we do it, when nothing else has happened before it. Again, it helps to skim and scan those questions to gain an understanding of how this is going to work. But at this point, it seems to suggest that each scenario that is given in each question is what would be happening the first time around before anything else has happened. Okay, so we cannot worry about the type of events we are dealing with, but perhaps more of what we are trying to look for. So we have 1.1. 1.1 says the probability that we get a number less than 5. In this case, these numbers are going to be 1, 2, 3, and 4, because 5 is not included. Remember, when you say less than, we exclude 5. So there's 4 of them. So we know that the probability of our event E, as described in 1.1, would be the number of those possibilities, which is 4 of them, divided by the total number of outcomes in the sample. So this is 1 over 5. So this is 1/5, which, if we choose to show this as a as a decimal, this is 0.4, right? Is it 0.4? Sorry, no, 0.2. Or we can show this as a percentage and say this is 20%. So we need to know again, because there's 3 ways we can express a probability. Is either a fraction, just make sure the fraction is the simplified version of it, although there seems to be not so much onto simplifying that fraction, but always try to simplify the fraction rather than to leave it raw. And perhaps you can do a decimal, which means you need to know how to convert between fractions and decimals, especially if you're going to be doing the NBT, and also to do the percentage. Okay, please know this, guys. So that is how we deal with that first question. So 1.2 says, what is the probability of taking out a number not bigger than 5? So this means it's either x is less than or equal to 5, okay? Meaning 5 is included this time. So how many are these? It's 1, 2, 3, 4, and 5 itself. Okay, so how many are these numbers? They are 5. So it means the probability of event E as described in 1.2 is going to be the number of those things, which is 5 of them, divided by the total number of outcomes in the sample. So this is 1/4 or a quarter. Now we know that this is 0.25, or this is perhaps 25%. So again, folks, know how to do this, especially by heart, or should I say mentally, or using some rules that you learned back in grade 8 of converting between decimals and fractions, and vice versa, of course, or percentages and fractions as well as decimals. So please, we need to know this. So this is cool. So let's do 1.3. 1.3 says, what is the probability of obtaining an odd number? Now we've got 20 possibilities. This is quite a lot. So sometimes it's not so easy sometimes to figure out these things. Because let's say that was 200, 1 to 200. That would hurt, isn't it? But questions like these, we can say, okay, how about we take a smaller sample of the big sample? Say we take 4 of these numbers. The first 4, so this is 1, 2, 3, and 4. The key here is that we knew that the total was an even number. The total of possibilities was actually an even number. Hence, we make our total here also to be an even number. That's the idea, because we want to study this. Now within this even number, we will appreciate that actually odd numbers is 1 and 3, whereas the even numbers is 2 and 4. Can you see there is 2 of each? So meaning it's 50-50. So basically it's always going to be 50%. So we can then transfer this and say, okay, in this case we've got 20 options. So 20 by 50%, this is going to give us 10, because 50% of 20 is going to be 10. So there's going to be 10 odd numbers versus 10 even numbers. But if you're not convinced, you may want to stretch this and say, okay, how about I've got 6 total possibilities here. The first 6 numbers, what happens? You count, you will see that it's always going to remain 50% as long as the total is an even number here. Now, we can safely say, okay, the probability of any event E occurring as described in 1.3 is going to be the number of these, which is 10 over 20. So this is a half. Right, so the 1/2 here is 50, I mean it's 0.5 or 50%. Right. So I'm sure by now guys are getting the hang of it if you did not already have this checked. So let's just keep going. Now we need a factor of 20. Now factors of 20, we can have 1 times 20, we can have 2 times 10, we can have, okay, 3 doesn't go, so this is going to be 4 times 5, and then 5 times 4. Now the moment we start reversing the last product in terms of the numbers, we know we have exhausted our factors of 20. And now each individual element here, this, that, that, and that. Since it repeats, we're not going to repeat it. Now each individual number there is actually a factor of 20. It means it goes to 20. So there's how many of these? 1, 2, 3, 4, 5, 6. So again, the probability of our event E as described in 1.4 is going to be how many? 6 of these out of 20. So this is going to be 2 goes 3 times, 220 goes 10 times. Again, we need to know how to do this. This is 0,3, or we can say this is 30%. Right. So this is, again, very easy question. I'm sure you guys now fully understand a few things. And a bit of logic, of course, is necessary. So 1.5, we need a prime number. Sorry, a multiple of 7, sorry. Now a multiple of 7 is a number into which 7 goes. So we know that 1 times 7 gives us 7. So 7 goes to itself once. So basically it's the very essence of this product that we are looking for. That's the multiple. 1 and 7 are factors of 7, but 7 is a multiple of 7. So know the difference. The second one, we can have 2 times 7. And this gives us 14. Again, 14 is a multiple of 7, whereas 2 and 7 are factors of 14. Again, we can see now, once we say 3 times 7, we get 21. But now we are limited by our ceiling of 20. So we cannot go further. So in this sample space, these are the only 2 multiples of 7. So basically, the probability of any event E in that sample space as described by 1.5 is going to be 2 of those over 20 possible outcomes. Now this goes once, goes 10 times. So 1/10 is basically a 0,1 or just 10%. Okay, so this is good. I'm sure you guys now can see, okay, all right, okay, this thing is very easy. So 1.6 says, what is the probability of taking out a prime number? Of course, the first time around, each one of those questions, it seems to be going that way. So what is a prime number? If a prime number is a number that has only got 2 factors. One of those factors is 1, and the other is itself. And that's it. Okay, so essentially that's what we can have, or this is what we have. So a prime number in this case is going to be 2, right? So prime numbers is 2. What about 1? But 1 is a different story, right? It doesn't start with oh, it doesn't start with 1, right? So prime numbers start with 2. I can just check something here quickly. Yes, they start with a 2, okay? Just to be sure. Of course, guys, when you're studying, some things sit in the background very blurry and dusty, so you need to get off the dust. So it starts with a 2, and then of course it's going to be 3, and then it's going to be 5, and then it's going to be 7, it's going to be 11, 13, 17, 19. And of course we could go on and on, but now our ceiling here is 20, so we cannot go beyond 20. So those are the prime numbers. So basically the definition is that these ones have only got 2 factors. One is 1, the other is itself. So the probability of any event E as described by 1.6, how many are these? 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be the number of these divided by the total possible outcomes in our sample space. So 4 goes 2 times, 4 goes 5 times. So this is 2/5, right? 2/5 is basically 0,4, or this is 40%. Again, know these things, guys. Know these things nicely. All right, nicely. All right, so this is good, guys. So let's do the last one of the basic questions. So we've got 1.7. It says we want a number greater than 10, meaning 10 is not included, but less than 16, again 16 not included, so this could be 11, could be 12, could be 13, could be 14, could be 15. So how many are these? 1, 2, 3, 4, 5. So we know that the probability of event E as described is going to be 5 of these out of 20 possible outcomes. We simplify, 5 goes once, goes 4 times, so this is 1/4 or a quarter. A quarter is 0.25, right? Or we can say this is 25%. Nice and easy. Nice and easy. So of course, guys, these were essentially introductory questions just to understand the issue of probability, meaning probability of any event E is the number of ways in which this event expresses itself, or it can be found, over the number of possible outcomes in the sample space where E is a part of. Right, because E is an element in that set. Okay, I hope this is clear, folks, and now we are comfortable, and I've shown you each way of expressing the final answer, so there shouldn't be any issues here. Now let's take some questions now which are going to perhaps get us to use what we understand. So question 2, we are told that if P of not A, that's the probability, so sometimes we can write this as P of A prime, then not A means A prime. Now what is that, guys? We know that this is a complement. This is a complement of the probability of A, because if we say not A, we know that the complement there is going to be A. So complementary events are going to kick in, and we should see already once we say complement, it means A and not A are literally mutually exclusive. Nice. Now that's the good thing that we need to know. So we're going to use complementary rules here, because we can see we were not told about the probability of A, but rather not A. So we are more likely to look for the probability of A. So we will use complementary events rule here. So can you see, guys, when you master the rule, then you know how to use the tool as well. It's going to be good. Now we are told that P of A or B, this is the union between set A and set B, is equal to 0.8. So already this is telling us that we will have our sample space. Let's put the tool, the immediate one is going to be our Venn diagram. So we've got set A, but of course seeing that there is an intersection between these two, so we might as well account for that and say this is B. All right, now we were told that the union between these two is 0.8, right? Meaning everything in those fields is going to be 0.2. Right. So now I'm thinking, okay, this is what we mean. So this is what we mean, folks. I wonder if I did not pause this for the previous work. If it is the case, then it's going to be too bad, because I don't remember what happened. So I just hope there's no glitch here. So when we say the union, basically this is for the union. That's what we mean by this. So it means everything in those fields added together. That's 0.8. Okay, good. Now we can see that ideally probabilities within the sample space should give us 1, because P of the sample should be 1, isn't it? Now if we see that A and B, which are part of the sample, they don't give us a 1, then it means what is missing is 0, 2. So this means this is outside. So the 0, 2 probability of other issues that are not part of A and B. So can you see we are now constructing our Venn diagram. And then of course we are told that P of A and B is 0, 4. So we always take care of the intersection first. So that's what we have. But now we don't know what is the probability of A as well of B, but we understood something about it. So in this case, we're going to then start working out things nicely. But let me just highlight something. If we have an intersection between events A and B, there's two possibilities. It's either A and B are independent, or they are not independent. Okay, so there's two possibilities here. It's either they are independent or they are not independent. Remember, an intersection does not merely means the events are independent. Please take note of that. An intersection between two sets does not necessarily means those two sets are independent of each other. No, it may be the case that they are not independent. Okay, they may not be independent, or they may be independent. So please remember this. But one thing for sure, we know that if there is an intersection, they are certainly not mutually exclusive. Okay, that is a certainty. So if there is an intersection between two sets, we know for sure those ones are not mutually exclusive. But when it comes to independence, we are not sure, because it will depend on some revelations that we may have to go at. So in any case, guys, I hope this is clear. As you can see, when you analyze given pieces of information and putting some sense into it in terms of the theory behind all of this, you will start to see how easy it is to work out problems in relation to that given scenario. Anyway, let's get to the work. We can see that we need to find out what is the probability of A here, right? So maybe let's label A differently so that we can be able to appreciate certain things. So A is all others. And let's give B a different color as well, so that we can clearly define all of these things. Okay, good. Now let's start answering. So 2.1. We know that P of A is a complement of P of not A. So this should be 1, because those two are mutually exclusive in a way. And so what are we going to do? I am thinking now, okay, we're gonna do it nicely. So this implies that P of A plus, we were told this is 0, 3, should be equal to 1. Now we jump for the jugular here. P of A is going to be 0, 3 taken from 1. That gives us 0, 7. Okay, easy stuff. So we knew that those two were complementary events. So we use the rule of complementary events. Can you see? Makes life a lot easier. So since we don't know the mark allocation, I'm not going to bother about it in this scenario. So now let's go back. So if the whole set A has a probability of 0, 7, and we already have 0, 4 in the intersection, it means A only is going to be 0, 7 minus 0, 4. So this gives us a 0, 3. So the A only is going to be 0, 3. So that's how we fill up this thing. Now we are missing B, and that's what we need to sort. So now we were told that, well, P of A, now we need to use our addition rule, because we've got P of A, we've got the intersection, and we're losing B. And we've got the union as well. So this means the addition rule will hold here. It's non-discriminatory. So P of A plus P of B minus P of A and B. Right. So we're told this is 0,8 equals, we calculated 0,7. If it is wrong, then the whole thing is going to collapse. Minus, we're told this is 0,4. Now we can go for the jugular again. Probability of B is, now remember, 0,7 minus 0,4 is 0,3. That taken from 0,8 is going to be 0,5. That's 50%. So again, we go back and say, okay, fine, probability of B is 0,5. We already have 0,4 in the intersection, so this means B only is going to be 0,1. So now our Venn diagram is complete. Now let's add those probabilities and see if we're going to get 1 for the sample space, because P of the sample should be 1. Let's see. 0,3 plus 0,4, that's 0,7, plus 0,1, that's 0,8, plus 0,2, that's 1. So this is good. So everything is perfect. So please guys know how to construct, interpret, and use the business that we see. Now we need to sort out 2.3. Now 2.3 says we need to find the probability of not A or B. That's the union. So what do we mean by this? Okay guys, as you can see here, we've shaded what is not A. Not A is everything else except that blue circle. So as you can see, we've shaded everything, including a portion of B, but we did not shade the A circle. That's what we mean by not A. So that's what we want. That's the union between those two. So we can say, okay, fine, P of A, sorry, not A, or B is going to be equal to, now we just use the Venn diagram as we see it. So everything that is not A is 0,2 plus 0,1, which gives us 0,3. And of course, this was already given here. But we can use our Venn diagram once we have it, if we did not understand. Now, O means plus, isn't it? B. But now if we look at B, we have 0,5. But the problem is that we already have the 0,1 as part of the intersection. So it means we're just going to add the 0,4. And of course, this means our P of A or B is going to be 0,7. Okay, great stuff. Now folks, you may be wondering, but why are we adding the 0,4? Because it's part of the intersection. Yes, but it's also very much part of B. So it comes in here. Okay, so sometimes certain things don't want to make sense when you look at them. But if you sit back and think about it, we've got options. How about we use our addition rule here and see if this works? So our addition rule says P of A, sorry, this time we're saying not A, or B is going to be P of A, not P of A, but P of not A, plus P of B minus P of not A and B, isn't it? So this is what we want. P of not A or B is P of not A was already given as 0, 3, but again we can just simply look at the diagram and say everything outside A, which is the 0, 1 of B and the 0, 2 outside, plus P of B. Again we can easily use the entire field of B, which is 0, 4 plus 0, 1, which is 0, 5, or we can use our calculation in 2.2. Now the issue here is that be very careful with this one. What is the intersection between P of not A and yet it must be inside B? Because this is suggesting everything that is not in A but which should be in B. We can see that is 0, 1, because 0, 1 is not in A but is also in B. So that's going to be 0, 1. And as you can see, that's literally the intersection between not A and that of B. They intersect each other on that B only, which is 0, 1. So again, know how to read your stuff. So this means the P of not A or B is going to be, now this is 0, 8 minus 0, 1. This gives us 0, 7. So usually if you use two techniques correctly, you get the same answer. You should be more convinced that your work is perfect. Okay. All right. Okay. Now, if we were just to add an extra question, is event A and event B independent? Because we said we were not able to decide which is which. Is event A independent of each other? So this is 2.3. So we want to know whether are A and B independent or not. So this is an extra question that I am adding. So this would be 2.4, sorry. So of course, guys, once you finish answering what you have, don't just leave. Think of different scenarios. Examine what you have done in as many ways as possible, because this is always going to make you better. But if you just answer the questions that are provided and you move on, what happens when that same diagram brings these other questions? You find this in your exam. Can you imagine such an advantage if you take care to explore things? So now this additional question, 2.4 hours. Are these two events independent? Let's see. We already know that P of A intersect B is already 0, 4. Now we can say also we want to know now what is P of A times P of B. Now P of A, as we could see, we got 0, 7 for A. We then multiply that of B, which is 0, 5. We will say this implies that P of A times P of B is, now let's see, half of 0, 7, I think is 0, 0.35 or something. Hey, ma. So 0.7 times 0.5. Yabona masendifuna ukuxoxa. Yeah, ndinyanisile. Yabona. Le nqondo isasebenza mos. This is 0.35. Now can you see, guys, 0.35, yes, rounded off to one decimal place is as good as 0.4, but not quite. That would be an approximation when we round off, but they're not exactly the same. So we can say, well, therefore, this is suggesting that P of A intersect B is not equal to P of A times P of B, because the left hand side is not equal to the right hand side. We can say therefore A and B are not independent. But of course they are not far from each other though. They are not far from independence. So this again, when this is perhaps some analysis of data, because remember, from summary we analyze, we use a model. You think about this product rule being the model of analyzing the data. Because remember, we collect data, we then summarize using our tools. From summary, we then analyze, which is these calculations, because we want to find out, are these two independent? Because we want to make a conclusion about the status of these two events. So they are not exactly independent, because we know that, of course, it's not very far off. They're almost independent, but they're not quite. It's like a matriculant and their parents, right? Matriculant is most likely somewhat independent, but not exactly independent, is it? Yeah, so this is more of that situation. So again, guys, be very comfortable doing your stuff, because if you're not comfortable doing your stuff, it's always gonna do you, and you don't want to be done. So that was just an extra question, guys, just to influence you folks to go back into the background and check if your stuff adds up. Of course, this is what you should do every time you do exam questions, whether on a worksheet or whether it's a study guide. Remember, the examiners are going to ask whatever questions they want, but think of other questions that are possible to ask in that given scenario, especially when you feel confident you've cracked that scenario entirely. Now you should be exploring more and more. The other thing you would want to explore is mutual exclusivity, but obviously in this case it's inferential, right? Because if we see there's an intersection already, they are not mutually exclusive. That's done. It's a done deal. But now we have made our conclusion, folks, about A and B. We know that A and B are not independent because of our product rule not holding true. So that's what we can say. As you can see, you cannot just say because there's an intersection, automatically these two events are independent. We have to check that. Again, we check this once we've done everything. As we said, the addition rule is non-discriminatory. It does not care what type of event you've got. It gives you the right answer. So if we apply it correctly, we get the right answers. We can then debate the issues of independence versus not independent. And then issues of mutual exclusivity, which this one is a clear cut. They are not mutually exclusive because there is an intersection. But you would be fooled to suggest that if there's an intersection, automatically they're independent. No, they are not. We have to explore the product rule. And if the product rule is as we summarized in our notes, then we say the two events are independent. Yes, if we were to round off to one decimal place, you would want to believe so, but remember, rounding off, it means you're correcting for something that is not quite there. So in essence, they are closely, in fact, they're very close to being independent, but they're not exactly independent. Okay, nice and easy, guys. Because what we got was a terminating decimal, so we cannot ignore those digits. Right. So I hope you guys understand all of this work here, so we can seal this question. And of course, if you've got any concerns or questions, pop them in the comment section below. And as I said, I will share this document in the description of this video. I don't know if I am allowed to share that other document, meaning the one that we're getting our questions from. But again, since it was freely available, perhaps, but you see, issues of being allowed and not allowed can really mess up everything. I hope, guys, we understood that. So as you can see, folks, with a clear understanding of basics, we can actually handle business nicely. So question 3 says there are 80 grade 10 learners, so that's the total in a school. 50 take mathematics, 50 take history, and the 20 takes both. As you can see, we've got two events here. It's either they're doing maths or history or both. Literally, that's sandwiched between the two. So we know that, okay, here we can do a Venn diagram, even if this is not stated. This is your first thing that you would want to think about. Because the story is already two categories with an intersection, so this is perfect for a Venn diagram. Right. Now, let's see. What are we going to say here? We will say, okay, our job is to try and get a Venn diagram across. So we know that there is this business, and we know there is an intersection because there's an and here. So that spells out our intersection. Great. So we can say this is M for maths, this is H for history. And remember, when we fill in our Venn diagram, we start with the intersection. So this is going to be 20, then we go outwards. So the math guys are 50, so we already have 20 down. So that means those who are doing maths only in this class are 30 now. The total giving us 60, because we said M is going to be this entire lovely space. Maybe I should have used the different colors in the first place. And then B, not B, but H, gonna be that whole little circle there, or set. Or we can say it's a subset of the sample, which is a set on itself. Nice and easy. Great. So now we know that there's 38 of those who do history. We already have 20 down, so it means we're gonna have 18 outside. This would total to 38. But now hold on, we're told we've got 80 students. So what is outside? Of course, at this point, we will just put down X because we don't know. We will say whatever is outside is X because we can see this is not adding up. But this X we can either work out nicely and say, look, we're going to say from 80, we take out this. This is 68, which will give us 12. Right? So we can either fill it up completely or we can just put down X. So now we are ready to tackle those questions because everything is ready. Steady. Go. So it says use the number of learners use the Venn diagram to determine the number of learners neither taking mathematics nor history. So this one is X. So we can just write 12 learners. My writing, guys. 12 learners. So that's the one. It's just 12 learners. This is if we decided to calculate this and represented it on our diagram. If we did not, what were we going to do? Well, we were going to say this is going to be X plus 18 plus 20 plus 30 should give us 80. And then this implies that our X is going to be 80 minus the sum of these, which is 68. Therefore, our X would be 12 learners. So depending on how we did our Venn diagram, if we chose X, we can just show our workings. But be very careful. When this question says determine, it's easy to just put down the answer only, depending the mark allocation is not 3 marks or more. If it is 2 marks or 1 mark, you can just write the answer. Nobody cares how you got it, as long as it is correct. But if the question stipulates clearly, calculate, you are not to present the answer only. You have to essentially show the calculation. because we lose marks, guys, by not adhering to instructions. So let's do 3.2. Now 3.2 says, what is the probability, or at least determine the probability that a learner takes mathematics only? And we can see this is the guy. So we know that the probability of M only is going to be 30 all over 80, the total, which we can leave as 3 over 8. Right. At this point, I'm not going to waste time showing you the other ways to express this, but learn how to do the percentage as well as the decimal, because you never know when that would be required. Alright guys, so this is sometimes as simple as it looks. So in the interest of time, I'm not going to start playing hide and seek, but yours, if I was to add, is taking maths independent of taking history. That would be the fourth question, because I need you guys to at least get used to these questions. Let's add this one. So is taking maths independent of taking history. So that should be a question for you students. Please shout out your answers in the comment section. Of course, you guys need to be interactive. I cannot give it all to you. Now that's your job, because we saw there is an intersection. They're truly not mutually exclusive. But now the issue of independence is somewhat a situation. Right. This is very interesting. In fact, I may want to add an extra question. Is M a complement of H or not? Okay, let's add another one. So let's say there's a 3.4 as well. So is taking maths a complement of taking history? Again, give the answers in the comment section below so that you can get to see. This is how you study maths, guys. You answer all the questions that are given carefully, making sure that you are as effective as possible, right? Because remember, you have to first be effective, then you can become efficient. You cannot just chase efficiency, meaning you're chasing time. You want to do this within the shortest time. At the same time, you're not learning anything. Remember, there's no point in sitting down and study if you're not going to make sure you understand the stuff and how it works and why it works the way it does. For me, I don't really recommend the time attack issue that many of your classmates or your peers tell you to worry about, because you see, that's the last thing you would do. In fact, the time attack is not even something you need to worry about practicing. It's automatic. You know, if you are given a time frame to work on, or within which you're supposed to work, there's no way you're not going to find a way of making sure you do everything within that time. But remember, when you don't understand, you will not keep up the time. And if you keep the time, you're going to fail, or at least miss your target, which may be a good mark, decent mark, or a distinction. You will miss your target if you chase time while you did not understand things. So you have to be effective, guys, meaning get things done properly. Then you can worry about chasing time. But that is automatic in the exam. You don't even need to practice it, because trust me, there is no point in practicing time attack. But at the same time, when you've got a lot of sections that you don't understand well, then you can start to think about time attack on sections that you understand. right? So that you can bank time for those sections that you don't understand. Again, in the exam, if you're sitting for an exam, you know that your time attack is only for the questions that you understand and you're comfortable with. There you will chase them. But taking care not to make mistakes, check your answers and make sure they are correct. Then you can bank time for those that you know, okay, I'm going to have problems here. And then you deal with those. In fact, the best thing is to start with those that you don't really fully understand so that you can use your clear mind to solve those problems as best as you can. Then you know with the little time you have available for the sections you're comfortable with, you can do time attack there. Right. So be very careful of what you hear people tell you need to do. Yes, these things people may say, but for me it works. Well, it's all right. If it works, it already means you have a clear understanding of the subject, because you wouldn't be successful in that if you did not. Okay, so don't hear what people say. They will tell you things that are impractical because they never sit down and think about what they're saying. And you sitting there at home desperate for some quick solutions, you will take everything to your detriment. Be very careful. Of course, this is what you would do. This is what I suggest you do when you study sections that probably you're trying to feel yourself around them. Add questions to these, provided you understand what those questions imply. Right? As you can see, I've added 2 questions, guys, because the rest was quite easy to deal with. But now the key is to enhance your understanding that, look, when there's an intersection, it does not always mean issues are independent versus not independent. Again, could it be possible that these are complementary events? Obviously, they are unlikely to be complementary events. Why? Because complementary events are mutually exclusive. God, I'm giving you the answer now. Dang! Sometimes you may be asked a question, justify why taking maths is not a complement of taking history. It's because there's an intersection. Complementary events, by definition, are mutually exclusive. So, as a result, this is not the case. Okay, so cool, guys. I hope you understand. So I've given you the answer for the last one anyway. So you may want to do the calculation to check if you want. But if it is not the case, then obviously it's not the case. But here you may just be asked a question, justify why this is not a complement. Or in fact, you may be asked, are they? And justify your answer. You may say no, because there's an intersection between M and H. If there's an intersection, it means these are not mutually exclusive. And if they are not mutually exclusive, they are not going to be complementary events, as you saw in our summary. Of course, I'll still leave you with 3.3 to do for yourself. Okay, guys, so I'll leave that space for that to be done. Okay, I'm going to move a bit quicker so that we can get a lot of issues done. But again, guys, time attack, as I said, is a fallacy. Don't do it. You can only do that on sections you're comfortable with, even in the exam. That's what you should do. Don't worry about putting time for probability if you don't know it. You're wasting your time. Don't even start with it, in fact, if you have no clue. Rather reserve the time for other important things that you stand a chance for. But if you know you have an idea but you're not comfortable, then start with it so that you use enough time and a free mind. Then time attack is only applicable for sections you fully understand, folks. Now, if you say, I understand all of topics for paper 1, then you can practice time attack, because now you just want to make sure you get your 100%. But that's what it is for. Otherwise, even if you didn't practice it, you would still come out with a distinction. That's for sure. Because the exam will always demand that you work efficiently. But what comes out of that is effectiveness. Are you effective? Can you get things done properly? Anyway, let's not talk. Now, there are 80 grade 10 learners in a school. 50 take mathematics, 50 take history, 12 neither take mathematics nor history. Can you see this is now the same question reversed? But again, we're going to do it nicely just to demonstrate this is again emphasizing another point. When given a question like that, because you may only have this question in your study guide, question 3 for example, twist it around. Play with that question. Put it apart, twist it, show it in different ways you can imagine. Because chances are, in the next exam, a question similar to this may actually look at it from the different angle you may have considered. That becomes your advantage. You get free marks because you thought about it and you had time to check that everything was proper. Because what is important about practice is that you will have enough time to check things. Of course, all I can say to you, when practicing or studying, just use reasonable time. Otherwise, don't really put a specific time per se, but reasonable time. Okay? Usually for me, what I used to do would be, if I feel I've done all that I can imagine about a particular topic, then that's it for me. And however long that takes, it doesn't matter. Or when I feel like now I'm overwhelmed, I'm no longer making much progress, before I make everything fuzzy, then I stop. But again, people are different. But remember, folks, we also have different goals in life. So at the end of the day, whatever I say may not be applicable to you because you have a different angle in which you want to use your education. For me, my job is to make sure that your education is as free as possible, meaning you can do as many things as you may want. I'm not here to quarantine you to one aspect of your education. All right, folks, so we've got again a sample space here that is 80 learners. Please, guys, always make sure you show everything. I didn't show it here. Always make sure information is summarized on your sketch before you go forward. Now, let's see. Question 4 says, yeah, same story. But now what do we do, guys? Well, this one says, use the Venn diagram, okay, to determine the number of learners taking both maths and history. At this point, this was not given. When it is not given, remember when we fill this up, we start with the intersection. So if we don't know, we put x, any variable. You can put a, you can put b, you can put m, but x is much easier and more recognizable. Of course, we can say this is m for maths, that would be h for history. Now we are told that there's 50 who do maths. Now we have x in there, so this means those who do maths only is going to be 50 minus x. And then for history, we've got 38. We already have x in the intersection, so this would be 38 minus x. That would be those who do history only. And we are told outside that there's 12 who don't partake in the subsets within that sample. Okay, at least in the set M or H. Now we need to find the value of x. Right. So with that situation, folks, with that situation, we will simply say, well, we know that x plus 50 minus x plus 38 minus x plus 12 should give us 80. Right, we add everything. So this x will take care of that x. So we end up with minus x plus. Now this is 88 plus 12. That would be 100. This is equal to 80. Therefore, we know that when we transpose x to the other side, it becomes positive. We bring 80. 100 minus 80 is 20 learners. Right. Very easy. Okay, folks. So this is cool. So we can just use our Venn diagram when it is carefully constructed. Very important. Let's say you didn't want to use the Venn diagram. Let's say sometimes the question just said determine, no Venn diagram. Let's say you don't know how to do it. So what would you do? We try the addition rule. So we know that the number of M union H is going to be the number of M maths plus the number that does history, right, minus the number that is in the intersection. Right. So as I said, master the rules, master the tools, be able to interchange. So this one is going to be the total, isn't it? The union is going to be the total minus 12. So this is going to be minus 12 equals the number that does maths, we were told is 50, plus the number that does history, we were told is 80, minus here, we don't know, we want to find out. Okay, good. 80 minus 12, this is 68. This is equal to 80. Minus n of maths intersect history. So therefore, the number of those who do maths and history is literally, we transpose this to the other side, it becomes positive. We transpose 60 to the other side. So 80 minus 60. That was not 30 but 38. So yeah, I was wondering now why the answer is crazy. This is 38. Sorry guys. So this becomes 88. Now 88 minus 68 is 20. Right. So folks, be comfortable doing your stuff. So this is what you would do if you did not think of the Venn diagram, because there are those who just can look and see and do. But some may look, see, but not be able to do. So folks, this is essentially how to do these things. This is what I emphasize again, guys. The technique is that please use what you can, but once you've done it and you're convinced everything is good, go back and look at a possible different approach. And as you can see, the addition rule holds for probabilities as well as numbers. As you can see here, we used numbers n instead of probabilities p. So be comfortable doing your stuff, guys. You will go far. Okay. So obviously, folks, this is similar to the question above. So the issue of independence, you can look at it. Again, it's going to be similar to the question above. So whatever answer you got above already comes in here. But technically, those are not mutually exclusive because there is an intersection that exists. So if they are not mutually exclusive, they cannot be complementary events. So play with the basics, guys, up until a point when you feel is good. All right. Okay, looks like my canvas was dirty from some previous workings. Okay. Now, folks, this is good. And then again, folks, to check if everything is tying. Of course, some coincidences will occur. So we know x became 20. So this becomes now 30. This becomes basically 18. And when we add everything up, we say 18 plus 20 plus 12. That gives us essentially 68 plus 12. That's going to give us 80. And if 80 holds, at least we can sit comfortably and say, okay, our stuff is done. So please be in the habit of checking if things are working nicely. So I hope you guys now are feeling like, okay, we understand how to do a Venn diagram and we understand how to essentially use it. And we can study our probabilities theory using it to prove and test the rules that we spoke about. So this is Q5. Okay, now I'm going to move a bit quicker, guys, because I don't want to lose time. Now I told you that a Venn diagram shows information about the number of learners who own dogs and or cats, or neither, right? So we know that those who don't own cats is 15. So that's good. And we know that those who own both is the intersection. So that's 5. And we know clearly that owning a dog and a cat are not technically mutually exclusive here, it seems. Yeah, that's it. So that's the case here. And therefore those cannot be complementary. But the issue of independence, we will find out. So we are told there's 100 learners in total. Great. So determine the probability that a learner owns a dog only. So that is essentially this. We want that over the total. So that's what we want. So basically this says solve for x. So sometimes you get given a Venn diagram, you need to be able to use it. So first we need to solve for x. Now we know that we have basically x plus 5 plus x into x minus 3 plus 15 should give us 100. So we've got x plus 15 plus 5 is 20. Plus this is going to be x squared minus 3x equals 100. So we see that we've got a quadratic here. So we can write it in standard form, x squared minus 3x. And then we've got 100 brought in, we're going to get minus 80 equal to 0. So we know how to factorize. If not, go for the quadratic formula. Some students like that. So which factors between, I think there's a mistake here. Yeah, there is a mistake. So this was supposed to be x minus 3x, so this becomes minus 2x. Okay, apologies for that. So please guys double check. Sometimes it's not always the case. If it is not factorizable, just use the formula, but just make sure the equation has no mistake in it. So now factors of 80 that can give us a 2 is 10 and 8. So that. So we know that therefore x here is going to be equal to 10. Why can it not be minus 8? Because x here stands for a number of people. We never have a negative number. It has to be a natural number, right? Right. So, or a whole number, should I say. So we've got 10 learners. Is it learners? Yes. Nice. So we've solved for x. Now we can say then, we know that the probability of D only is going to be x, which is 10 into 10 minus 3, all divided by 100. So we go on, this is going to be 7 times this is 70 over 100. So this is basically 7 over 10. Again, this is 70% or 0.7. It's not a big deal after all. So can you see guys, this one was a two-step thing. We knew that we needed to solve something. Again, to prove that x is correct here, we go back and sort it out. So this is going to be 70 and this is going to be 10, right? Now let's count. This is 70 plus 10, that's 80, plus 5, that's 85, plus 15. You see, that's going to be 100. So if everything comes up nicely, we know our job is done. Okay, we've answered the question. and we are happy. Now folks, is owning a dog or a cat an independent situation, or is it not? So let's ask that question. Is owning a dog or a cat, or is owning a dog and owning a cat, let's put it that way, and owning a cat independent, right? Again folks, this is the question I expect you answer in the comment section. Please tell me, is that the case? Because we know that when we have an intersection, it's either we have independent events or we don't. Right, so that's the question for you guys. Please answer it nicely. I'm leaving you with that. So let's look at question 6. So question 6 says, there is a vendor at a sports match selling hot dogs and cans of cool drinks. Can you see this person is just selling that? Maybe other things, but we are looking at this vendor in terms of selling hot dogs and cool drinks, okay? Nothing else was mentioned. Now the hot dogs cost 40 rands each, and cool drinks cost each 15 rands. Right. Now we don't know how many issues here are in our sample, whether we are looking at students here or participants or spectators. We don't know how many people are in this event, so we don't know. And what we see though is that we've got 18 things here. What could those things be? Of course, these are the people who bought a hot dog only, and we've got 36 people who bought a cool drink only. Like myself, I don't really like to eat in front of a lot of people. I would rather drink than eat. So yeah, that would be me buying a drink only. Ndiyaqhifiza mntabawo, ndiqhaphe iwesi xa ndinentshebe ndiqhaphe naloo ntshebe neminwe yonke loo nto ndizingcolise, so ayingeke ndiba neentloni. Abanye abantu ngabanamsebenzi alve bezosula khona apho, umntu azafinye naphambi kwabantu. Yho, yandi-irritate loo nto leyo. Ewe kona into ebalulekile, kodwa yho Nkosi yam, ndiyayiqonda uba nesigqwathi sikhe sisalela apha empumlweni zikrobile ungaziboni. Uzabunyanyisa abantu. Hayi, ayantwana ezibindi kodwa, but mhlawumbi ndinengxaki. Anyway, leave that one alone. Okay guys, so we understand what we have, and of course, since we have an intersection, we know that these two are technically not mutually exclusive, because we have an intersection. And if they are not mutually exclusive, it means they are not complementary events either, because complementary events need to be mutually exclusive. So technically no. So the issue is that of independence. Again, you would actually tell me. Now let's find out. It says here the vendor received a total of 2,855 rands now out of selling. It says now determine the number of people who bought a hot dog and a drink. So basically this is basically solve for x. So we need to solve for x. So what are we gonna do, folks? Interessante thing is there. Okay. We don't have the total. Yay, when I think the questions are kakubi, and then khona nemali khona apho. Ifuna ukusiphambanela ne, ifuna ukusiphambanela, but but we know that these are not mutually exclusive, so okay, now remember folks, this to me spells out a situation like this. All right, so this means we are dealing with a union of H and C. This is what yielded the 2,855. So I don't see how I'm gonna use this 32 right here. I cannot figure it out. Because at first I wanted to use the 32, but I don't have the total. So if I introduce another variable, it's going to lead me into a horrible situation of simultaneous equations, which I don't need at this point. So how would I just get to this? Man, this question looks crazy, man. So if this is a union, it means the total number of people there multiplied by each category. So this is how we're going to do this. We will say, okay, fine, we understand that the 2,855 rands was taken from. Now we go and see here. What we see is that these guys bought the hot dog only, right? Let's not use that. So those ones, the 18 bought the hot dog only. So this is going to be 18 times the money for each of those hot dogs. So this is 40 rands, right? Right, plus. Now, we get to the intersection. These guys in the intersection bought each a hot dog and a cool drink. So this means it's going to be the number of those guys multiplied by the price for the hot dog. But now we're going to repeat them, because this time we're repeating them for the cool drink, right? And of course, we add those that bought the cool drink only, which is the likes of me. So this is 36 times 15. Okay, this looks right, because we know now we're going to multiply the number of these individuals and the price of what they bought. But the intersection in this case is going to show up twice, because those guys had two things happening. So yeah, I think that's the best way to go about this. So we simplify our business. 2,855 equals, so this is 40x plus 15x. So 40 plus 15 is going to be 55. So we have 55x plus, let's see, 18 into 40 plus 36 into 15. This gives us 1,260. So we will see that our x is going to be 2,855 minus 1,260, all divided by 55. What do we see there? So that's what we get. And then we divide this by 55, it gives us 29. Remember, this is the number of learners. Okay. So here we just had to apply logic in a way, because we didn't really necessarily use the rules. But of course, I think at this point, we understood the union here. That's what gave us everything, but we used our union together with our logic here. We did not necessarily use the rules. So this is the case, guys. So x is 29. Now we may be asked a question, how many people? In fact, one may not even ask this question. The other question that is possible here, if you think about it, if we didn't concentrate on x, we could even ask how many people bought from the vendor. Konje bought ubhalwa kanjani? Oh, Nkosi yami. Bought from the vendor. You see, this would mean we want the sample here. Now, how many people were present in the event? No, let's not say bought. How many people were present in this event? Okay, so this is a possible question. Why would Devin call this number? They don't know this number. Afuna upgrade this ngenkani hlanyela. Asibayekeni befona kanjalo because bathanda usinonisa ngegadgets xa baserobhe laba raba abo neck siphela la baqhaba phambane ngenye imini udlola impama mfana impamanyana. Okay guys, so I'm too relaxed and time is flying and I don't like it. So can you see guys, one may ignore this question that was asked and just jump for that big one and say how many people were present in this event, meaning we want the number of people in this sample. So it means we solve for x first, then we calculate how many folks there are here. So we have 32 plus 36 plus 29 plus 18. So it means there were 115 people. Okay, so this question can really go that route as well, and it'd be like what. So please try to think of different questions and answer those questions that you thought of. Okay, great. Now I would say again, answer that question so that you make sure you understand these basics. Is owning, is buying, this time we're not owning, is buying a hot dog and a cool drink independent. Okay, see, the reason why I keep pushing these guys, I want this idea to be clear in your heads, because you will come across higher grade questions that have this as their basis and you will cry because you will feel like you can't do these questions. But if you make a habit of always trying to identify the basic things within a given scenario and check it out, you will always be in a clear view of things. So again, throw it in, write down question 6 and highlight the issue here, that independence or not. You say yes or no. And of course, justify this by showing me the situation. Of course, here you may not necessarily show the calculation per se, but just show the end result that justifies your conclusion. Right, so we are done here, folks. I'm not going to answer that question for you, but these are the things you do whenever you are given a situation. Now, this is a typical exam question. So this is what you are likely to get. Once you see a shopping list like this, and some categories within that shopping list, or a shopping list that fits into those categories, you know that a Venn diagram is going to come in. Of course, categories that may have an intersection within them, within them. So how would you know this? It's something like that. So it just skim and scan if there's an intersection within the categories geography, history, and economics. You've got 3 events here at least with elements fitting into each category, and there's an intersection, a Venn diagram. So this is the things, guys, we just want to make sure you are comfortable identifying. Ne? I don't like not knowing things. You should know things. Right, so this is question 7. Again, guys, I'll leave this space for you to write notes on, because I'm going to provide this going to provide this answer sheet at least in the description for download, so that if you want to use it as some document to work on, you can add some extra notes and whatever calculations you may need to do if I added some extra questions. So question 7 says, at a school, a survey was carried out to determine the number of grade 12 learners who take geography, history, and economics. Now, the following information was collected. 135 learners took part in the survey, so the totals are very, very important to note. So that's the total number of learners. So we know that our sample space has 135 learners. Now, 5 learners take geography and economics, but not history. 12 take geography and history, but not economics. 24 learners take history and economics, but not geography. Can you see the ands are the highlights that there is intersections within these categories at least. So this is again another clue that a Venn diagram is going to be more useful here. Y learners take history only. X learners take all three. Again, that's the grand intersection. Y learners take economics only. 2y plus 3 learners take geography only. 60 learners take economics. Now, the number of learners who take geography is equal to. Now, I see there's another piece of information that you must not forget. Extras are very important because there are certain things that are going to make it impossible to solve. So this is a highlight that, okay, we may need to use this. We will see. So the number of learners who take geography is equal to the number of learners who take history. Right. So obviously, guys, the question just says determine. Now, whichever method is necessary, do it. But obviously, you would know that with that kind of arrangement of issues, you certainly are not going to get very far if you did not at least put down a tool, one of the tools. And the best here is the Venn diagram. Again, you can see how we identified the necessity. All right, so let's do a Venn diagram, because without it, those questions are going to be horrible. So we have something, okay. Chechala kwana wena. Tronvetsa gore le boteng la eng mona tlontena o nketsa diphahla ha ke tenuwe nna ska tlontena ha ke diphahla hantle nna ke tlo pitsa wa bona ska tlo ipitsisa ka nna ke diphahlo tse nyane ntse o le mogolo wena ka mmele wow ska tlonkgentsha ebile I'll constrict you like a python. So folks, we've got our geography, we've got our history, and we have economics. Hey, as I'm not about words. Yeah. Okay, so folks, we've got this situation, and remember when we do this, we always start with the intersections. So we've got X here, we're told, so that is checked. So always take what is you checked, because this is a lot, you can forget things. Now we start with the minor intersections. Now we've done the grand, so we go to the minor intersections, any one of them. So we know that 5 take geography and economics, right? Geography and economics, but not history. So this means this 5 is here. All right. And then we are told that 12, of course, that one must take so that we don't repeat it. And then 12 learners take geography and history, but not economics. Okay, so this is going to be true. The 12 is over there. Again, this is done. Now 24 learners take history and economics, but not geography. So this is 24 right here. Okay, so this is good. You see, everything now is falling into space nicely. So y learners take history only, so there's y here. And then X is sorted, Y learners take economics only. And we were told that those that take economics, no, I'm lying. Okay, let's forget it. Okay, that's what we have there, Y and Y, so it's sorted. So 2y plus 3 learners take geography only, so we've got 2y plus 3 there. And we are told 60 learners take economics. Can you see this is yet another somewhat a proper rule. So it means 60 learners take economics, meaning so this means these folks should add up to 60. Okay, so that's very important. So can you see there was a bit of extras of information here. Were we told about those who do not take any of these subjects? No. We are not told anything about those who do not. So this means we need to think about this situation right here. So this is going to demand a whole lot of work. Okay, guys, let's just work through it nicely. So we know, and but I'm a bit unhappy here. Did I miss something? Why do we not have those who don't? Anyway, let's forget about it. So we're going to try and use these two rules, right? These two rules are supposed to be the key here, because we know that the number in our sample is 135. We will see. We don't know what's outside, but at this point we're not going to worry about it. We're going to just leave it as we see it. Maybe we can say this is P. Let's not use P, that's for probabilities. Let's say it's K, because we don't know. Is it there? Is it not there? We will find out. Now, let's use the rules. We were told that 60 learners take economics. You know, but I'm feeling like, is this one going to help me? It's going to have X, which I don't like at this point, and Y. So I don't like those two variables together. So maybe let's take the second rule. It says the number of learners who take geography is equal to the number of learners who take history. So we know that, okay, N of G is equal to N of H. That's what we are told. Now this implies, all right, so we've got 2y plus 3 plus 12 plus 5 plus x. Everything in geography, right? Everything in geography we're going to put in there. This point we're focusing on totals. And we're going to take everything in history. Right. So that is x. So geography is 2y plus 3 plus 12 plus 5 plus x, and that's it. So this should be equal to, this is y plus 24 plus x plus 12. Okay, don't worry about other things here. So all we know is that essentially x takes x out. So we are good. And the 12 takes the 12, because in any case it repeated. So what do we have left on this side? We've got 2y plus 3 plus 5, that's 8, equals so we'll have just y plus 24. So this implies we move the y to the other side. Y is going to be, in fact, we can make a conclusion at this stage. We don't want to waste time. Therefore, y is 24 minus 8 is 16. Now remember, y represents learners, so this is 16 learners. Nice. Nobody told us to do it. We had to. So y is 16. Now if y is 16, it means this one is also going to be 16. And this means here we're going to have 2 times 16, that's 32, plus 3, that's 35. So we've got 35 in there. And we don't know the value of x. Okay, so this question was crazy. Also, we know that the number of economics is 60. So this implies that we've got 16 plus 24 plus x plus 5 is equal to 60. So we can just go for the jugular right now. Therefore x is, let's see, this is 60 minus the sum of 16 plus 24 plus 5. This gives us 15. Okay, again x is the number of learners, so this is 15 learners. Okay, so this was a bit of a hectic question, I tell you. So we know now that x is actually 15. Okay, I want to see what I can do there. So we know that we've got x, which is equal to 15. Right. So now we've worked out those missing values. As you can see, nobody asked us anything, so we had to show these calculations. Otherwise, we would be in trouble. So this takes us to 7.1. Of course, in 7.1, before we can answer that question, these calculations need to be present, are they not? So you would see that that 7.1 would carry more marks. But at this stage, I'm just going to do those calculations there and answer the questions. But remember, everything we've done, we need to show. So it's either we say 7.1 and then we deal with this. We can say then. Maybe let's do that, probably. That would be the best way. So we can say 7.1. We are given this, then we get the answer, and also given that, we get the answer. We can answer the question at the end. Then we are supposed to find the probability of G or H, probability of G or H, and E. So what do we know about this? So G or H and E. Can you see? Basically what this is saying is this. So essentially, guys, this G or H is the union between G and H. And as you can see, it's going to be all of those numbers. And of course, you can do this using the addition rule. Calculate it separately and then deal with the other part. But now when we say and E, so this means we want the union of G and H together, or the intersection of the union of G and H as well as E. And where are those? Now we can see that this is the one, this is the one, and this is the one, because that is where E intersects the union of G and H. So be able to read this thing. So this is easy when we look at this graph. So we will see that this probability now is going to be just those numbers. It's going to be 5 plus 15 plus 24 all over the total, which is 135. Now let's do it quickly. Okay guys, I'm not gonna go beyond 3 hours on this on this work. So, but at the same time, take this as a course that can help you understand things. So guys, we're getting 44 over 135. So this one does not simplify. So if this is the case, we'll leave it here. Of course, you may want to do this as a percentage if you want, or perhaps as a decimal to 2 decimal places or 4 decimal places. But just to protect ourselves, we can do 4. So we can say 0.3259. Or this is going to be 32.59%, just to keep 2 decimal places for the percentage part. Okay, so this, guys, is exactly how this is going to look. So essentially, guys, this is it. This is it. Hope this is 100% career. If it is not career, it is not going to be very nice. Okay, now folks, as I said, remember, when you're studying, you don't want to cheat yourself of understanding how to use things properly, because you will always have a problem. Sometimes you don't know how to read these things or interpret these things, because you wouldn't understand that that is actually the intersections that you're looking for. You wouldn't think about it. You'd be like, icon, what if this is wrong? Now let's do the addition rule. What about the addition rule? So we can say P of G or H, right, and E. Now I'm going to use the addition rule already in the right manner, right? So we know that it's going to be equal to the P of G or H plus the P of E minus the P of this G or H or E. Okay, so I'm writing it already ready for me to solve, because remember, if the rule is written in a particular way, you can twist it around depending on what you're looking for. So basically, we were looking for the intersection. Of course, we can write it the standard way, you know, or write it in any way, but at the end of the day, this is what you're going to end up with. So if we simplify here, G or H, it's everything in that field. So this is going to be 35. I'm just going to show everything here. This is 35 plus 12 plus 15. Okay, let me be clear. Doch. Okay, so this thing is doing me wrong. So this is plus 12, right, for that intersection, plus 5. This is what I don't like, man. These things just become too close. Plus, so can you see this is 35 plus 12 plus 5 plus 15. Right, plus. Now, we've added those ones, so it's going to be 24 and 16 plus 24 plus 16, right? Maybe let's move it a bit to the left so that we can have enough space. Of course, this is another option there. So plus those of E, it's going to be 24 plus 5 plus 15 plus 16. So this is 24. This is 16 plus hold, you can load. Yeah. I think here the best is to use the numbers, because it's gonna hurt us. Let's use the numbers instead of the probabilities. So let's use the numbers so that we can do the probability later. Okay, so those would be the numbers. So that would be 16 plus 24. I'm just trying to take you through this nicely. So 15 plus 5. So we're saying basically everything in E. Right, so we will then say that, maybe we're gonna drift it a bit back, just so we can be able to accommodate the last thing. As much as I don't like my issues not aligned, I'm gonna do it anyway. So let's move it a bit. It's not gonna be nice. So folks, now we're gonna have to add everything in G, H, and E. Can you see? We're just saying the entire field. The last part is the entire field. So it's gonna be everything within those circles, right? So this one is gonna be ugly. I'm just gonna add them on the calculator and put the value, right? So this is gonna be 16. I'm just gonna point out so that you see what I'm doing. So this is going to be 16 plus 24 plus 15 plus 5 plus 12 plus 16 plus 35. Okay, so this gives us 123. So you know what that is or how that came about. Okay, good. So let's see what answer do we get. So we had here 35 plus 12 plus 5 plus 15 plus 24 plus 16. That's an answer, 107 plus. We then add 16 plus 24 plus 15 plus 5. This gives us 167. So this is 167 minus 123. Okay, maybe let's just do the wrong thing. I don't like equal signs that do this. So we say minus 123. It gives us 44. Can you see? So we can say therefore the probability of G or H and E is going to be the number, which is 44 over 135. Done. Can you see, even when we use our addition rule for the number of those people or learners to then calculate that probability at the end, we can see that it still holds true as long as we know how to do it. So guys, I was just pushing you a little bit further because you can see when you do the rule here, it's more complicated than when you understand how to read from the sketch itself or the diagram itself. But it doesn't mean you wouldn't be able to do this. Okay, so that's the one. So that's the one. So that's 7.1. Now 7.2 says we need the probability of G or H and E. Can you see? The intersection between H and E or G. So where is that? So H and E, there is that intersection. I'm going to highlight it differently. So basically, guys, this is the situation that we have here. We either have the intersection between H and G, or we have G as a whole. So this is how we would shade this. Of course, now you can see everything is a bit complicated, but what I like is that you can actually see what's cooking. So this one is easier again if you know how to read. So we can say the probability of G or H and E is going to be all those values that are in there. So the intersection is going to be 24 plus 15, right? That's all. But now we're going to add everything that is in G. We can add plus 5, plus 12, plus 35. So this gives us 91. So this is 91 over 135, the total. Now let's see, divided by 135, it doesn't solve any better. So this is it. Okay, so guys, learn how to do things using the diagram. And of course, I tried to assist with the shading so that you can understand what you're supposed to do. Okay, so this is it, folks. Again, could you use the addition rule here? Now, let me leave that to you to try and see if you're going to come up with the same answer. So I'm going to say try the addition rule to solve 7.2 and see for yourself what happens. Of course, this will demand that you know how to use the addition rule in this instance. If you don't know how to use the addition rule in this instance, you will be punished severely. Right? Right. But let me be friendly to you, just show you how it's done, because I know you students sometimes. So we know that the number of G or H and E. Now this is the union, right, of these. So it's going to be the number of G plus the number of H and E, right? Minus the intersection between G and H and E, because you need to know how this is done. Okay, so this is a bit silly, but what can we do? So we go on. Number in G, we know the number in G is basically 35 plus 5 plus 15 plus 12. So it's 35 plus 12 plus 15 plus 5. So this is 67. So this is 67 plus. Now H and E is just this intersection right here. So it's just this. H and E is just going to be 15 plus 24. So that's 15 plus 24. That gives us 39. So we've got 39 here. Minus. Now this is the intersection between H and E. As you can see, the intersection between H and E, as well as the intersection of G. So where is that? It's just 15, isn't it? Because that intersection is basically just there. So what we are saying here is the intersection of G as well as H and E. So H and E, as I said again, is this part. Now we want this part to intersect G. That's going to be just 15. So we're just going to subtract 15 here. Again, please be able to do these things, guys. There is no excuse here. So let's see, we've got 67 plus 39 minus 15. It gives us 91. Can you see? It holds true. We can say, therefore, the probability of G or H and E is going to be, I was supposed to put an extra bracket there, is going to be 91 over 135, which we can show this as a decimal, we can show it as a percentage, or we can show it as a fraction, which this one is the simplest we can get. So as we can see, guys, if you know how to read things, which I tried, honestly, remember, guys, the length of this video is not about just getting to the point. I know many of you are obsessed with short videos, but do you really learn anything from those short videos? Well, you think you do, but come exams, you are the ones who cry. Believe me, 80% of the people who prefer the shorter videos, no matter from who, those are the ones that always go like, that exam. They never really do well. Or they miss their targets. That's the idea. It's either you don't do well or you don't get your target, whatever it was. But those who have the patience, folks, to make sure they study things, they understand things, and they can do things effectively, then they become sufficient. That means they will surpass their targets. Most of the time they will surpass their targets, whatever that target was. If you just said, I wanted a pass, you'll end up with a decent mark, a merit. If you wanted a merit, you'll end up with a distinction. If you aimed for a distinction, you end up with closing on to 100%. That's always the case, folks. So you decide who you are. Again, I'm going to make these videos for everybody. Even if you're a learner who's fast and slow, these videos are going to be good for you, because every time there's something that is always common with the studying. You take your time. Studying takes time. When you say you are studying something, it means you're examining something. And you cannot do a quick fix in an examination. You look, you check, you twist, you turn, you poke, you squeeze, you stretch, you contract, you do many things, man. You put in different scenarios. You want to see what is the behavior of this thing, given the common scenarios around it, so that you can understand and predict its behavior. So that's studying. So when studying, there's no way you're going to be quick and run. If you do that, you're not studying. You're just passing time. Oops. No pulipeni. You're just passing time. And if you pass time, folks, you're going to lose. As you can see, folks, you can look at it directly. You can work it out. As long as you know how to construct the rule and you know how to ensure that you read your diagram properly, you will always succeed. But if you do not do the things right, you're going to always suffer. This one is already complex. Let's leave it for the other things. I'm sure you as a student seated at home, you already know what to do. Okay, now let's get to the next question. So now I'm going to move a bit faster, guys, I hope. Question 8. Now question 8 says a bag contains 6 blue marbles, 5 green marbles, and 4 red marbles. See, again, we've got 3 scenarios here, or 3 subsets of the main set. The main set here is the bag. These are all subsets, that of green balls, blue balls, and green marbles, blue marbles, as well as red marbles. Now it says 1 marble is drawn from the bag, the color is noted, and then it is returned. Now once we return, what are we trying to create? Independent events. Right. This is the idea. Of course, it's not necessarily the case, but I would assume, or at least figure out this. If we're returning it, it means the probability of drawing the next ball or marble is not going to be affected by the fact that we have drawn this or any other ball or marble before. Now, so the second marble is then drawn. Can you see? Obviously, once we do it sequentially like that, and we are returning this thing, it means we are creating independent events. So this is suggesting so, and we know now, once we get independent events, which may be 2 or more, we can use a tree diagram. So this is now a question that is suitable for a tree diagram, as I have highlighted above. Wow, this thing just moves itself in the pelagagbi. But yeah, this thing is sensitive. If you move your fingers quick, sometimes it does that. Anyway, second thing is we need to determine the probability that both marbles are red. So can you see now we've got a situation. This one says determine. So again, if you're comfortable doing this, you can just do it. Right? If you're not comfortable, don't do it. So there are some people who may need a tree diagram. There are those who may not need a tree diagram. Maybe I'll try to show you both, understanding for sure what these events are. If you can understand that, you either do the tree diagram or you don't. So let's show you now. What is this? But I'm going to show you the tree diagram first. So the tree diagram has 3 things. 1, 2, 3. So it can be any one of the 3 that we would draw the first time around. Right. So this can either be a blue ball, could be a red ball, it could be a green ball. Okay, that's the first thing. And then when we draw the second time around, this could either be a blue ball, could be a red ball. Maybe let's make it look soft like that. It could be red, it could be this could be the scenario. Okay, so we could still get a blue, we could get a red, we could get a green. Same for this situation. If we drew the red the first time around, the second time around we could find ourselves getting a blue, a red again, or a green. The same will happen there if we do it the second time around. We could find ourselves drawing a blue or a red or a green. So that's our tree diagram, folks. It's nice and easy. Okay, we need to master this technique. It's very important. Now, folks, we are saying we want a situation when both balls that we drew are red. So what are we looking for? We're looking for this arm only, because the other arms are going to combine blue and others. So we just want that arm. And now up the branches, we saw that these are either independent or not independent events. So these ones are independent. So this means, what would be the probability of drawing a blue ball in the first instance? How many are they? Sorry, a red ball. Oh, I made a mistake here. So if we want both of them to be red, so this is the scenario. That's the arm that we want. So that's R and R, okay? So essentially, what is the probability of getting a red here? How many reds did we have? 4. So this is going to be 4 over the total. How many are these? So we've got 11 plus 4, that's 15. So that's going to be 4 over 15. Can you see that? And since we returned it, it's going to still be 4 out of 15. So we know now that to answer that question, 8.1, this probability of getting red and red, some people may even write it this way, probability of R intersect R, still the same thing, is going to be that probability times 4 over 15 again, isn't it? So multiply the probabilities, and we saw that these are essentially independent events, so that should be true. 4 by 4, that's 16. 15 by 15, that's 225, is it? 15 squared is 225, yes. So this is going to be 16 over 225. I don't think we will be able to change that. It stays as it is. Yes, yes, and yes. So as you can see, guys, you need the tree diagram sometimes to identify what you need to do. Then it assists in ensuring that we do it right, okay? So this one, guys, belongs to this part. I'm sorry, it's just that the diagram became too small. So I was supposed to write it there, but because of space, I had to write it out. Okay, it's not for the blue, but it's for the other red. So as I said, folks, if you understood that these are independent events, you don't even need the tree diagram to answer that first question. You can just go straight to the calculation. But the tree diagram will help you in other type of questions where if you don't have, you will not be able to survive. You will see as we go along. Now the first marble is blue, and the second marble is green. So basically here we want the probability of B intersect G. And we saw that these are all independent events because we keep returning things. So the probability of getting a blue and getting the green is not affected by the other. So these are independent events. So we can do the product. So basically we want this blue and green. So now where is this? So we said the first, mind you, the first must be blue. So this is already this arm. And then the next one must be green. So that's what we want. So again here, it didn't just say one of them must be blue and one of them must be green. There's a difference there. This one is specific. The first must be blue and the second must be green. So this is that yellow arm only. So again, we multiply the probabilities there. So getting a blue, how many blue balls were we having there? 6. So this is going to be 6 over 15. And then the green one, how many green ones did we have? 5. So this is going to be 5 over 15. Okay, I'm not sure. I'm going to write it nicely there. So Papa Wena. So I'm gonna write it here, guys. So this is gonna be green. It's 5 over 15. This is a third. Okay, so that's for that part, guys. I hope it's clear. It's just because of space there. So now, once we have everything done, we just simply multiply the probability. So this is 6 over 15 times a third. Again, you can write 5 over 15 if you will, which will give us the answer. So this is basically 6 over 45, and that should be okay. Yeah, 6 over 45, funny enough, 3 goes, okay. So 3 goes twice, okay. I wasn't aware, I was crazy. Sometimes you overlook things. So this is going to be 2 over 15. Okay, good. And of course, as I said here, this could still be written as P of B, G, like that. It's one and the same thing, so don't get confused. So I'm trying to take you through these things, guys, slowly. I know you're gonna be angry with me, like, the videos are boring. Look, if you don't want to learn, go away. Okay, a blue and a green ball are drawn. Can you see this time doesn't specify which one should be which one? One of them must be blue, one of them must be green. So I like this question. So how are we going to respond to this? Now let's say, okay, blue. So we can have a blue and a green. So again, this may overlie that. So we can say blue and green. The yellow one that we have is there. And again here, the first one could be green and then the next one could be blue. Can you see it's either that arm or that branch or the other branch? So it's one of the two, because at this point we don't know which one. So this is a union of these two. So basically the question is saying it's either we have BG union, which is or GB. So that's what this question is asking. So be able again to read statements and understand how to put them down mathematically using the right symbols and giving the right scenario. So this is what we have, folks. So BG, we saw that we already did it above. Okay, BG was 2 over 15. We're not gonna do it again. That's if you're confident your answer is correct. If you're not confident, let's say this was the first time it gets asked, you would write 6 over 15 times, the other one came out to be 5 over 15. Now we said or, we're going to add. Now GB. So GB, how many of these ones are green? So this is 5 of them. So this is going to be 5 over 15. And then B was 6 over 15. So that one is good. So we're going to say 5 over 15 times 6 over 15. Can you see this is more or less the same thing? We're saying that times 2. Right. So basically this is 2 over 15 plus 2 over 15, which is just going to be 4 over 15. Nice and easy. So again, guys, you can look at this in terms of decimals or not. Again, you can just put it on the calculator as it appears. 6 over 15 times 5 over 15. That multiplied by 2. So, Okay, the 2 are supposed to be on the other side. Okay, we can say times 2. So we get 4/15. Okay, good. So as you can see, guys, you need to know again how to read a tree diagram. Can you see, if you did not have it, you would probably not know what to do. But again, those who do know what to do, they may not need the tree diagram. Because if you can write this rule and you can do those probabilities, because you know that that product is going to be what it is. Of course, as I said, it's either they are independent or not independent. It doesn't matter. But here we clearly understand we created independent events here. So we're not unsure, we are very sure. Even when they are not independent, with a tree diagram kind of a scenario, it will always be clear. There's no question about it. So understand the strengths and weaknesses of each tool, and of course the specifics of each tool. Wow, I'm talking too much. I'm like a preacher. Okay, guys, in the interest of time, I'm not going to explore other things. Here it's all about knowing when to use a tree diagram and how to use a tree diagram. Okay, slowly we are creeping to the end, guys. Question 9. I'm going to try, though, to exhaust all these questions. How many are there? So we've got, Yana, 16. Okay, we need to move. We need to move. Okay, now I've taken you through the tree diagram. Now we know we're gonna use it again here. It says now this again, the same scenario. One marble is drawn from the bag, and then the second marble is drawn without the first one being replaced. Now, if we don't replace, we're creating not independent events. Okay? Because now the probability of drawing the second ball is affected by having drawn the first ball, as the sample space shrinks when we take out the first ball and not return it. So can you see, it's always clear. So when these ones are not independent events, we are going to use the tree diagram still. But all we know is that the product rule in this case doesn't hold true. The left-hand side is not equal to the right-hand side, as we stated in our notes. So this is cool. So again, folks, let's get this thing done nicely. No rushing, just doing our things. I'm gonna okay, let's make it a bit wideish so that we don't have 10 go. Difuna ibe ngathi straight man. Difuna ibe straight le ndaba ibe ingoma kamabrr man kodwa niseyintwana. I-straight le ndaba. Right, this could be a blue marble, could be a red marble, it could be a green marble. Then we draw the second time around. We've got 3 possibilities. Yes. So this could still be blue, it could be red, it could be green. Again, we've got this scenario here too. So we could get blue, we could get red, we could get green. That one also has 3 lovely possibilities. So it could be blue, red, or green. So now let's see. What are the probabilities here? Now it always helps to fill them up, but again, sometimes to avoid wasting time if other questions are not asked, you don't really want to stress too much about each individual one. So we're going to just attack them as we see. So it says determine the probability that both marbles are red. Can you see? We want them to be red, so same questions. This one. So what's the probability of getting the first one? There were 4 reds, so it's going to be 4/15, right, in total. But now if we took out 1, there's only going to be 3 out of 15 the second time around. Can you see? No, out of 14, not 15. So can you see the number from which we can take the possibility shrink as well as our sample space? So this is the scenario that we're asked in the first instance. Again, for those who know how to do this, they won't need the tree diagram. So we know that we want the probability of red and red, which we can express as P of red intersect red. So this is going to be basically, the first one is 4 over 15 times 3 over 14. Okay, let's move. 4 over 15 times 3 over 14. So this gives us a 2 over 35. Okay, again, you can express this as a percentage or a decimal. So folks, easy, né? So this time you can see not independent events. How do they look in terms of our tree diagram? Again, for those who master this, they don't even need that tree diagram. But try to first use the tools. When your understanding is solid, then you can just jump in. But don't try to jump in without understanding. You will fall. Because there's always catches within these questions. 9.2 says the first marble, can you see there's a restriction? First is blue, and the second is green. Again, so we know that we want our situation to be like this. The first is blue, so this is this arm, and then the second is green, so it's that arm. Now let's do those probabilities. Getting a blue the first time around is going to be 6 over 15. And then getting the green one, the greens were 5. So this is going to be 5 over, now we've already taken 1, so it's going to be 5 over 14 this time around, because these are not independent. So we can say probability of B and G, which you can easily write as probability of B intersect G, is going to be 6 over 15 times this one is going to be 5 over 14. Right. Remember, there was a specification that the first must be. It's not like either one can be. Okay. Okay, guys, bear with me. I know it's annoying what I'm doing, but for the sake of those learners who really need the understanding, not 4 but 14, yeah. So those who need proper understanding here, this is 1/7. No, like that. Okay. So, like Deben doesn't know this number, guys. Hey, man, can't you penseka? Ayingafonela inamba yami ingaziwa. No man. If non first band upgrade nina. Ngicela kabe. You can't upgrade me, guys. Where's not the upgrade? I go upgrade. It's a lie. For me, an upgrade should be before the contract expires. Say, for example, my gadget still has a year to go, because usually what Vodacom does gives you true upgrading, because before the year your contract ends, they can allow you to take a new gadget. Of course, it will increase your premiums, but you can. So that means you can own 2 gadgets before that contract expires. But now MTN is lying. They are just wanting you to finish the contract, and then they call you upgrading the package if you're getting a data of this sort, and then now you can just upgrade it on the same gadget because that contract is gone. That's like maintaining that contract unduly. So no, this is a chicanery. MTN is crooks. Vodacom may be a big crook by not paying that guy, but they somehow do something good. But they are terrible when you want to cancel the contract. Oh, they will want you back in. Anyway, guys, that's it. It's done. So as I said, it's either you know or you don't. But if you don't know, try the tools. They will assist in then understanding what rule to use. And as you can see here, the product rule is your friend here. But even the addition rule might be used here, depending on the question at hand. Right, and right. Okay, so be careful though. Here the product rule is the best, and the union here, you better use it wisely. I would say. So 9.3. Now it says a ball is blue and a ball is green. Now here there's no specification, so this is suggesting that we are either going this way. Can you see the difference of how these questions come? Or this way? Can you see? That's the union of those two arms, as I said. So we can see that this is basically probability of either blue and green or green and blue. Right. So what are we gonna do? We will deal with those probabilities nicely. Now this one, for green, the first instance is gonna be 5 over 15. And then blue is gonna be 6 out of 14 because we have contracted our sample stuff there. So the first one, we've already done it above, but we can do it again. 6 over 15 times 5 over 14. Or means plus. The other one is gonna be 5 over 15 times 6 over 14. Okay, this one is slightly different. So we just do it on the calculator. So I've got 6 over 15 times 5 over 14. Why do I keep writing 4? My lord. Okay, it looks like my concentration is also lapsing now. Okay, don't go. Damn it, man. 6 over 14. Yandrwela jwala. Nakwatlo dryla ke ntweni. Ntwe sa bua imfela. Aya tshwanela ho dryla hampe. Wow, warning. Ka se ke kwatile mona. O tlo nkga o sa bola. Ke o jwetsa. I tell you. It's gonna smell without rotting, okay? There's gonna be hydrogen sulfide smell without the actual hydrogen sulfide. Yes. Okay, guys, so can you see that is the thing? And if you think about it, it's more like doubling that thing there. You see? It's more like doubling that thing because it's more or less the same thing. Is a more or less the same thing. Eh? Yeah, it's not that's a difference. It's not. So, guys, this is nice, isn't it? Now, my question is, can you use the addition rule here? I think about it. Maske sigiye kucinga. Asikushiye ucinga. Can the addition rule be used here? So this is for you guys. You can tell me. You note this. Is it possible or not? Give the answer in the comment section. I want to find out. If yes, motivate. If no, motivate. Okay? I don't take guesswork lightly. If you start guessing, I'm going to insult you. Okay, I'm joking, guys. I'm not going to insult you, but sometimes I want to link to that angle of saying, if you're guessing, I'm going to start to horrify you. But if I do it, then I'll be killing your confidence. And that's not the goal. Alright. Hey guys, le moto bazoyiqeba nini? Phela guys fanele if I gqitywanga le moto izondibulalisa. Like seriously guys, yo. Izondibulalisa if I gqitywanga namhlanje. Izondenzisa into endingafuni uzenza guys, like seriously. I really don't like to mess up, but anyway guys, unfortunately people have to deal with it, however the consequences, because what can I do? My position is just not allowing me to do otherwise, or else I'm gonna lose more than I would keep what I'm trying to keep. So yeah, I might as well lose. If I lose, I know the loss I can take on the chin anyway. Right, folks. Yeah, that's the one. So your job, guys, is to find out if at all the addition rule can be used. Please make that note for me. If yes, show me how. If no, show me how. Okay? All right. Okay. But the essence of it, if it is good, you will get this answer. If it is not good, you will not get that same answer. And if you're not getting that same answer, obvious. That's the motivation for you. But then prove it, okay? Yeah, you must just prove it. Now, guys, comes a past exam question from May, June 2022. Now let's see, we learned how to construct the tree diagram, and we learned under what circumstances we can do it. Now let's see, in an exam situation, how would we handle a question that involves a tree diagram? Okay, now it says there are 120 passengers on board an aeroplane. Not aeroplane. Sometimes it's called a city aeroplane. Somehow in class we always like to change things. It's like drag. We say go Greg. Then class is sort again go grade. Especially sitting go trade. We always somehow do that in class. I don't know why. It's so easy to mess up like that. So even aeroplane, we say it's an aeroplane or aeroplane. Not aeroplane, but aeroplane. We say aeroplane. Okay, passengers have a choice between a meat sandwich. Is it sandwich or sandwich? Wow, that word always horrifies me, because some people who speak nice English, they don't say sandwich. What should we say? I guess we're gonna take that route back to where it came from. In certain languages like French and other things, certain syllables you don't say, or you say them differently than the way they are written. So perhaps it links onto that, because some people like to, if I went to France, if I'm going to talk about, what word is this? Wow, the word just disappeared now. Okay. So, for example, you talk about Benoit. Is it Benoit? Chris Benoit. You know, most the wrestler, Chris Benoit. But you see those that know he is French. I think he's from Canada or wherever. So they don't say Chris Benoit. It says Chris Benoit. Wow. So you might say things like that, if you understand those things, because you're trying to look like, yeah, I know French, but I don't know French, so I don't have to say it right, So leave me alone, please. I'm not interested in trying to be nice. I'm getting rough now. Anyway, guys, so sandwich. England, but sandwich. Snacks. So ngayibiza ke wena ngamagama snacks, because you're kwezinye indawo ezifense and bazibalulekile, mna zibalulekanga kum. Okay, a cheese sandwich as well. So can you see we've got two categories, or two things, or two subsets within the set. Now, cheese sandwich and a meat sandwich. Now we are told a story that but more people or passengers will choose a meat sandwich. So now the question is, what is the utility of that statement? Well, if you're my student, you attended our classes, you already know what this means. Or if you are a person who watch my videos in this channel, you may have seen this video from way back. So if you saw this, you probably also know But for now, let's pretend you and I don't know. So we'll find out what is the significance of that statement. Now, there are only 120 sandwiches available. Can you see? In our sample space of sandwiches, we've got 120. Now, out of 120, we are told more passengers are going to choose the meat sandwich. What does this suggest? It's suggesting that the cheese sandwiches are less than the meat sandwiches. It is that way. It is that way. But we don't know exactly how many are the meat sandwiches. We don't know exactly how many are the cheese sandwiches, but all of them add up to 120. So if we say the meat sandwiches are X, for example, then the cheese sandwiches are going to be 120 minus X. Please, guys, there's no manga business. So this is obviously a higher grade question. So babies in probability who did not understand the previous few questions that we worked on and don't understand, the summary that I gave you, and perhaps don't have access to it, or you don't have access to someone who can explain, well, you're in trouble, guys. So, hey, guys, let's go on. Okay, so now it says the probability that the first passenger, now hear that word, first passenger chooses a meat sandwich, and see, there's an intersection, and the second passenger chooses a cheese sandwich, is this friend right here. So this question is packed. So you can see that, folks, there's no way you can just jump in a question like this. It's already taxing your brain from the start. Now, a student who answers this question last and is not good, they probably are getting 0 here. But they won't even know what to do. But a student who knows they can do probability, but they're probably not strong, they will come here first, use as much time as they can, but please use a reasonable amount of time. Don't be crazy. Sit for this and lose time for other questions. But try to use as much time as you can possibly use, of course, within reason. Then do your best. So you may walk away with some marks. But of course, if you did listen to the introduction of this video, or should I say the beginning when we summarized this, now you would know, okay, we've been building up confidence. So folks, it says now calculate the probability that the first passenger will choose a cheese sandwich. So we have to answer this question, and as you can see, we need our tools here. So now the good thing is that we only have 2 choices. It's either we're doing a cheese sandwich or a meat sandwich. So we can just say the meat sandwich is M, then the cheese sandwich is C, sorry. Great. So we either do that choice, and then of course, the second time around someone chooses, they can either choose again a meat sandwich or a cheese sandwich. And those that chose, the first person, if it chose, he or she chose a meat sandwich, a cheese sandwich, then the second person could either choose like that as well. So as you can see, it's a very nice simple tree diagram to handle. But now let's deal with the issue. Before we do this, we can say let the number of meat sandwiches be equal to X. This implies that the number of cheese sandwiches is going to be 120 minus X. Please, that statement must come out, because we don't want to find ourselves dealing with an X we don't know. So this is such that we have that tree diagram. Now we are good. So what is the probability of choosing this thing? Remember, cheese sandwiches, if one is chosen already, out of the total, we have shrunk. So these are essentially not independent, logically independent events. Because if we've already chosen something, the second person is going to choose from a total that is less than the original. So it helps again to understand what type of events do we have available, of course, if that is clear. Now, a meat sandwich, we said these are going to be X, so this is going to be X over 120, which was the total, so this is good. Now choosing a meat sandwich again is going to be x minus 1 because we've chosen 1 already, divided by, now the total is no longer 120 because we already took 1, so this is 119. Can you see what's cooking here? I'm sure you can. Now choosing a cheese sandwich the second time around is going to be 120 minus x divided by, again we've already made a choice, so this is going to be 119. We come here, what is the probability of choosing a cheese sandwich? So this one is 120 minus x over a total of 120 at first. Now choosing the meat sandwich after choosing a cheese is going to be x over 119. And then this one is going to be 120 minus 1 is going to be 119 minus x over 119. So again guys, please, there's no questions about this. Please do this all the time. Yes, I kind of became sloppy here because I was just aware that the questions are simpler. So sometimes just do it like I did this one. You see a question like that, question 10, this is how you approach it. You do everything, you don't skip and scan because this is quite simple. But when it is overwhelming, you will see what you need to do. Okay folks, now this is all that we have. So now let's get to the question. The question said the probability of choosing the first passenger choosing a meat sandwich. So now the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich. So this is this situation. So can you see? We are told that that branch, which is going to be P of M and C, we are told this is going to be 18 over 85. Okay, so at this point, this is what we know is coming up from that arm. So can you see, this is the idea that we are being told here. So we know that probability of basically M intersect C is 1/8 over 85. This is what we are given. So this implies, now what is P of M here? This is x over 120. Now we know we're going to multiply these, right? Yes, so this is 120 minus x over 119. This is equal to 1/8 over 85. So can you see we've got an equation and we can solve for x essentially. But remember, that's an intermediate question because the question is, what is the probability that the first passenger will choose a cheese? Meaning the question is here. This is what we need to solve. But now we can see that what helps us to solve that question is x. Okay, so let's sort it out. So we go on. So when you multiply, x multiplies there. So what? That's the one. So we've got here 120x minus x squared, all divided by 120 times 119 is basically some ugly number there, 14 squared, 32 and 80. Right. So dila ngazo lezi numbers ngokuzihlanya. Sometimes it doesn't help. So at this juncture we cross multiply or whatever you can do, but cross multiplication is the essence of it. So all we have here basically is 120 times 85. So we've got 10 squared 32 x minus 85 x squared equals, so 18 times 14 squared 32 and 80. So it gives us Yeah, 257 squares and 40. All right, so that's the one. So we can see this is a quadratic. We move everything to the right and then rearrange. So we've got 85x squared minus 10,200x, and then this is going to be plus 257040 equal to 0. We divide by 85. So this is x squared minus, so since we saw that we multiplied this, so this should work. 10,200 divided by 85 gives us 120. X plus that one, 257040 divided by 18, 85 is 3 quarter and 24. Now this is a quadratic equation. Yeah, some students would prefer the general quadratic formula, but you know what? I am a freak of trying everything I can. So what I'm gonna do, I'm gonna say this 3024 equal 3024. We shift and fact. What do we get? Shift, factor. We get here 2 to the 4 times 3 cubed times 7. Now our target is to manipulate this so that we can get 120. Yikes. Okay, let's see. This one is already not going to work the way it is. Let's split the 2 to the exponent. For usually the clue, guys, is to split the highest exponent there into some smaller. So we can say this is 2 squared times 2 squared times 3 cubed times 7. Let's see. Now this is 9 times 4, that's 36. Let's see. 36. So if we take these, that gives us 36. Yeah? So 36 plus, let's say 2 squared times 7, that's 4 by 7, that's 28. All right. This is 4 times 7, it gives us 28. It gives us 64, not 120. So nope. Es ni verkimos. Alright. Now let's split this 3 as well. The next one, we split the next. So we can split, did I say 9? That was 27, man. Yarato. That was 27. Oh Lord. Okay, maske siyeke kanje, sitting with 3 cubed. Did 9? That's why I'm suffering. Damn it, man. This was not good, man. That was cubed. So this is basically 4 times 27. That's 108. Ne? But 108 plus 28 is already bigger than 120. It's 136, so it's not going to work. So this says, let's split. There's nothing we can do to the 7. Let's split this to 3 squared times 3. Okay? So now let's see what we achieve. So we're going to say 9 times 4. That should be 36. Ne? And then let's take the remaining. So this is going to be 4 times 3 times 7. It gives us 84. Now let's see, 84 plus 36 is 120. Yebo. Yes, these ones add up to 120, so that's good. So we're gonna say this is 84, 36. Now these are both positive because the middle term is negative while the last is like that. So of course, guys, this is a bit of work. If you don't like it, just go straight to your quadratic formula. There's no harm in doing that, but you know what? Just get things done. So we've got x and x there. So in this case, we know that x is either 36 or x x is equal to, maybe let's not say therefore, but it implies that x is 36 or x is equal to 84. Now the question is, which one do you choose? Because now they are both positive numbers, so they are very much possible. So are you able to just choose whichever you like? Then goes this statement that said essentially more passengers will choose a meat sandwich. So it means there should be more meat sandwiches than so meat sandwiches are greater than the cheese sandwiches, because how can people choose more if then they are less? So this means therefore x here is 84, not 36, because of that statement. So sometimes there will always be enough information for you to choose. We can say then we understand that the probability that the first passenger, we can just say event E as described in that question, is going to be the number of ways, which is 120 minus x is 84 divided by 120. Therefore, the probability of our event E here is going to be the one answer. 120 minus 84 is 36 divided by 120 is 3/10, which is 30%. I just like to leave it like this to avoid trouble, unless otherwise I'm forced into a particular direction. Maybe if the question says what is the percentage, you know, yeah, or maybe round off your answer to 2 decimal places. See, this one either forces one into a decimal or a percentage, because both you can do that rounding off. But if nothing is said, just leave it as simple as it looks. So can you see, guys, this is no question you can answer. If your algebra is weak, this is why we always said no algebra, no quadratics, and no one is gonna tell you how to solve a quadratic. Solve it. And you can use it as a means to an end, as you can see. So guys, this sums up the question on how to use tree diagrams. When the question is hot and you can see without the tree diagram, we would not make a headway into solving this question at all. So this is just to emphasize the importance of the tools. Okay, let's keep going, guys. We have to seal. Now, of course, guys, you will decide if you want to watch this video or not. But those who want to learn, they will. And they will take it for as long as possible. Because you may find that this video actually will turn up to be more important and more clearer than going into a class 2 times and not hearing what the teacher is doing. I'm not saying teachers must not be listened to, but I'm saying there are times when you realize the class is just not helping at all, because it doesn't help cement anything. It's just going through the motions. So it's a waste of time to go and attend, because the reason for attendance is to be made more aware than to just go through the motions. You can do that by yourself. Do your trial and error, win or lose, doesn't matter. But if you want to ensure that you win more, then you need to be more aware. And awareness is going to come from clarification of why things work the way they work. And that needs a bit of time. Okay, guys. So it says now events S and T are independent. Can you see? This time it's given. Now, what do we know about independent events? It means P. So that statement means P of S intersect T is definitely going to be equal to P of S times P of T. So the addition rule is true, meaning the left-hand side is equal to the right-hand side. That is true. But with not independent, we can still use the product rule, but it's such that the left-hand side is not equal to the right-hand side. That's just the difference, okay? Now, such that P of S is equal to P of T. So can you see these two things are equal at the same time? And both of them are equal to Y, okay? Now we're told that the union is this. So since these two are equal, you can just divide this by 2 to get the probability of each, because the union is when we add the two. Now, we have a situation. Is that true? No, it's not. So that's wrong. So can you see? Wrong, wrong, wrong. You see, now I'm being silly myself. And you would be so silly as well. But remember, there is an intersection. So if there's an intersection, the union is not just the addition of those, but it means we need to subtract the intersection. So be very careful. This is the idea right here. So this case scenario, we said the P of S is equal to the P of T. So the union is going to be Y plus Y minus the intersection. Now, the intersection between these two, since they are independent, is going to be Y squared. So that would be the union, and all of this is going to be equal to 0.84. This is when we are using the addition rule. So I'm sure you can see where we're going with this. It's again going to give us quadratics. So it says find the numerical value of Y. So here, a question like this, as you can see, it's a past exam question. And in this case, we just need to understand the rules and sort it up. But again, one can still do a Venn diagram. It's not going to hurt. So whether you do it, whether you don't do it. So I'm going to let you do the Venn diagram yourself. Okay, let me not be silly, guys. Let me just try and show you things. So whether you do it or you don't, it's not a problem. If these two are independent, it means they will have an intersection for sure. So we've got T and S. So now, what do we know? If they are independent, we know that there's going to be an intersection. But that intersection is going to be such that it is Y times Y because of that. So if this is Y and this is Y, the product is going to be Y squared. So we write here Y squared. Start with the intersection, provided we know how these are related. Very important. And then we are told that the union of these two, meaning all of these fields, like so. So it means all of those fields, they add up to this situation right here. Now you can see that we are supposed to find the probability in the sample space to be 0. So we know that the probability of our sample should be 1, sorry. Now we're getting 0.84. It means there's something that is outside. So what would that be? If this is 0.84, so we say 1 minus 0.84. My brain doesn't want to work anymore. So this is 0.16, okay? So always make sure you draw this right, and we go. So now we were told that the probability of T here is essentially Y. Now we've got Y squared here. So this is going to be Y minus Y squared, isn't it? It should be like that, because we need to take out the intersection. And I am like, what? Huh? Yo. This is not so nice, is it? Because can we imagine when we take Y, let's say Y is 2, then 2 squared is 4. Can you see it's going to give us negative vibes? Wow. I don't like it. I doesn't like it, but it is what it is. It is what it is. Yay! Aye, man. andikho right ke ngoku, andikho right. Andikho right. Itheni ngathi ifuna ungabikho right nje. Hayi man. Yho. Hayi, iyandihlanyisa. Masike singayigcwalisi liyaphatha ingathi ifuna ukusipayisisa. Masike siyeke nje net so. Because that calculation is starting to not look right. And when it doesn't look right, izosifaka engxakini yabo. Masingayivumeli. Yikes. Yani. Okay, because these ones are probabilities. Yeah, guys, andazi mani bona undifumana ndimenta wenenye. Ifuna undigulisa futhi. Ifuna undihlanyisa straight like that way. Anyway, we want the value of y after all. So I was just thinking, folks, we're just going to use the rule here. I don't know, as incomplete as it is, but if we write it now, it's going to make no sense, isn't it? It's starting to not make any sense. So is a speed. Let's just use the rule here and say, okay, the probability of S or T is going to be the probability of S plus the probability of T minus the probability of S intersect. Since we used or, let's just use and. S and T. Now we know that this, we were told, is 0.84. This is going to be equal to this is y plus y. Now we're told these are independent, so this is going to be y squared. Okay, so we go on. So we've got 0.84 is equal to 2y minus y squared. Now we have a nice quadratic. We write it in standard form. It's going to be y squared minus 2y plus 0.84 equal to 0. And of course here we don't have a choice now. We just have to use our quadratic formula. So we know that y, okay, we can just first write it and say y is going to be equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Remember guys, we need to show the formula before substitution. So this is minus into minus 2 plus or minus the square root of minus 2 squared minus 4 into 1 into 0.84. And we get our answer, but I'm thinking this equation looks strange. Okay, but anyway, 0.84 times 4 is going to be a smaller number, right? Yeah, 4 times 0.84 is a smaller number than that. It's 3, so we're not going to get a negative under the square root, so we can say y is equal to, obviously we will check. If we look at this equation, you know, we've got a smiling parabola. Just think of it as a smiling parabola, just to determine how the roots are going to look. So this is x. In fact, now we're going to have y, but it doesn't matter. We can say y, even though this is in terms of y. Now we know that the y-intercept is positive, right? And we're going to have two roots here. Where is the axis of symmetry going to lie? This one, because this is negative, the axis of symmetry is going to be, and of course this is negative while this is positive, so the axis of symmetry is going to lie to the left of the y-axis. So it means our graph is going to do stuff like this. Right. Now this is the story. Can you see we will have this root and that root? They are both going to be negative. Now that is quite a disaster, isn't it? Okay, let's see. So we're going to have minus into minus 2 plus into the square root of minus 2 squared minus 4 into 1 into 0,84. How yaphumi positive hayi ke ngoku 10 ngathi ngiqhelwa kabi. Hayi man, is minus hayi doch man. Yo, you see the sketch misled the guy. Yo. No, my sketch is betraying me. Remember, when this is negative and this is positive, because it's going to be minus b, it's going to be positive. So the graph is like this. Okay, so that's how the graph is going to be. So we're going to have positive values. So that would be x, that's y, when that's, yeah, okay. So I'm getting y is 7/5. Right. Now y, remember y is the probability. Is it possible for the probability to be such a number? No. So y cannot be this value because this is 1,4 and y here is the probability. It's not just the number of things, it's just the probability because that's p of t. So this is not possible because that's 1,4. So y is, let's see what is the other one. Okay. The other answer is 3/5, okay? So 3/5 is literally 0,6. Is that possible? Yes, because the probability should be between 0 and don't. So maybe we can write this like this for now. We can then make a conclusion that y should be 3/5, which is 0,6. Now that is good. So can you see, again, as much as we got positive values, how do we decide which one should be correct? Is understanding what we are given. If we're given a probability, it should be between 1 and 0. So that 7/5 is already greater than 1. So it's 8. So as you can see, guys, we've solved this nice and easy. Again, you can see this is a higher grade question also. This is not a standard grade question. So here, maybe understanding the rule was more important here than the actual diagram, because the diagram started to not make sense when we did this. But now you can see where is the sense in this. Actually, we are allowed to say y minus y squared. You know why? Because the square of a proper fraction is even smaller. Now we can safely say, okay, hold on, this is possible. So that's what we need to do. So we know our stuff is done properly. Okay, now our stuff is properly done. So essentially we know that, okay, since this comes out as a probability, in fact that's what made me to doubt myself. As you can see, there will be instances where you don't immediately think of the correct thing, but as you go along you're gonna, oh, I know now. So if I'm squaring that y, it's definitely going to be way less than y itself. So yeah, now I can write that thing that way. So you can now finish your stuff and present your answer. As you can see, guys, don't forget functions. As you can see, this is still a function. And if you understand how to interpret functions by just looking at the equation, and approximate how things are gonna be, you are home free. Because now you need to know, okay, out of those two values of x, the roots, which one is correct? And we can see it's the smaller one. So meaning the root that we're looking for is that one. And this one is wrong because it's greater than 1. Probability cannot be more than 1. You see now? Can you see? Functions are going to be brought in here at some point. But at this stage, we just applied our knowledge without necessarily needing it. But this is when you want to ensure that, okay, I know what I'm doing and I know where I'm going. Okay, guys. I hope we are good. I hope we are very good. Very good, very good, very good, very good, very good. Okay, folks. Again, we don't know the mark allocation, so we're not going to focus on that. But it was more of drawing the tool, but the tool immediately didn't try to make sense. But if we realized those are the probabilities, not numbers, then we know it is okay, because y squared is going to be a lot smaller than y. So, but it didn't come out immediately. My teacher, when he taught us in grade 7, he forced us to buy dictionaries, and then immediately he would say, write this down, immediately. Essentially just giving us how the word is spelled. Immediately. Yes, yes, yes. And then he would say, look it up in the dictionary. What is the meaning of it? So you would write the word down first, then write the meaning by looking it up in the dictionary. So in essence, you would have to get the right spelling by checking it with the dictionary, and then after that you give the right answer. And then of course you'll get a serious hiding if you come up wrong, the word as well as the answer. Oh, that man ambushed us. He butchered us. The cane. Yo. Alright guys, so sisabethwa ngamaqala sinjalo sigqibile la question, and now there's no doubt that our Venn diagram is proper. And if it is proper, now let's count the probabilities, because we want to check if this is good. Remember, sometimes you calculate and you don't know what's going on. Now this is how you're gonna check. If y is 3 over 5, so we're gonna write 3 over 5. Right, now we want to know what is that squared. So wait, 3 over 5 all squared is 0.36. So this is 0.36. All right, and what is this gonna be? So now we've got 3 over 5 minus 0.36. So this one is 0.24. And this is going to be 0.24. Now let's add everything up. So we've got 0.16 plus 0.24 times 2 plus 0.36. That gives us 1. And that tells us there is no way in hell, if not in heaven, that we are wrong. We are the right ones. Yes, we are the right ones. Okay, guys, I hope you're enjoying the course. I like these questions, man. That lady who compiled these is the best. But you may find that this is not a lady. Hey? Sometimes the names these days are unisex, they say. Is it uni? No. Multisex? I don't know. Whatever. Suzanne, you may find that it's a guy nowadays, because hey, we have guys that are given girls' names, and guys also call themselves whatever, as well as girls call themselves whatever. But I would believe that's a woman. If not, I apologize for saying things. Okay, guys, we stop here. Now, we know that these are independent. Again, that would be another way of proving if everything is right here, because you want the intersection to be equal to the individual probabilities essentially. So we know that 0.36 is indeed given by the product of 5 over 3. Remember 5 over 3 is the probability, there is 3 over 5, sorry. That times times itself, that is 3 over 5 squared, it gives us 0.36. So indeed, the independence is proven again. So that's another way you can prove that the answer is correct, okay? What am I saying? Is that you can prove that the P of S intersect T is indeed P of S times P of T. Okay. P of X intersect T is indeed P of S times P of T. And in this case, the left-hand side is equal to the right-hand side. And so this proves independence, which means what we were given, we did not distort. So please, guys, check your solutions. And I think I've given you enough to do that job. Okay, now we're done with tree diagrams. Now let's talk about contingency tables. So this exercise 12, or question 12, is going to give us contingency tables in a nutshell. So I told you a tuck shop offers the following choices for lunch. You may either have a sandwich, or however you want to say this, or a pie. See, that's two categories, right? And you may either have a juice or a bottle of water. Can you see? We've got 2 by 2 categories, sandwich or pie, drinks, juice or water. Can you see 2 by 2? This is what you call fertile ground for a contingency table. Categorical data, 2 by 2 minimum or whatever. So this is it. So now it's done, luckily. Sometimes it may not be done for you. You may have to construct it. But once you see what I just showed you, it's already indicative. So there's a mosquito, he's trying to take a bite in me. And I'm not giving it the drink. I don't have blood for crazy things. Let me drink something too. And I'm hungry as well. Okay guys, yabuya. Bengingafuni le video ibende, but sevele yabande. Yabalibende. Yalazi ibende intoni? Nge-English. Ibende ilento kuthiwa si-spleen in English. Is the spleen. So bengingafuni ibe libende lento man, ivele yaba isi-spleen. Ivele yaba mtanana, yamazi utanana. Isihlubi. Sithi ibende ngutanana. Kodwa ke not ngesihlubi per se. I don't know if sisihlubi kodwa ndiyacinga ukuthi noba sisihlubi, but elalini ne unodiphu ne, andazi unodiphu ke ngesingesi kuthiwa yintoni, but kulaa mntu ocontrol idiphu elalini. So wayenikezwa ibende xa kuxhelwe inkomo elalini. If elalini kuzawuxhelwa inkomo for whatever reason, whether umsebenzi, andazi kodwa kwi-funerals, andikhumbuli kwi-funerals, but xa kuxhelwe kungumgidi, ibende belithathwa lisiwe kutanana. But of course not lonke ne, but bekesikelwe half yebende ulise pha lidliwe nguye utanana. So sasithi ngutanana ke la tata, wayebizwa ngotanana, I think ngokusisteketiso sakhe. And then bese sithi xa sesikhupha ibende enkomeni, but only elenkomo ne, not impahla like igusha nebhokhwe. So ibende belithathwa ke lisiwe kwatanana. So sasesigqibela sesilibiza ngotanana. Ndiyacinga uba nje kwaba yiloo nto nje elalini. unless ke ba eso steketiso naye wasithola ngoba ibende liye libizwe ngotanana as well, andazi. Okay guys, too much comfortability. Sine questions eziyi 2011 here. So now nazi izinto sizinikiwe. So guys, contingency tables, we know that this row must add up to 250. So if we've already got 200 and the total is 250, it means here we have 50, because when we add these two we must get 250. And then again the total downstairs like so. It means if the total is 50 and we've got 30 already, so here we must have 20. Okay, now we get stuck. So we read more. It says the probability of a person choosing a juice and a sandwich is 0.48. Okay, can you see? This is the intersection and the probability of, so this means this is the case here. If we said this is X, juice and a sandwich, now we want that probability. So we know that we will then work out. We can say let, of course, we can say let the number of juice and a sandwich, right, be equal to X. So this is very important. So this implies that the probability of juice intersect sandwich is given by 0.48, which also implies that we've got X over, what was the total of these people? The grand total is what gives us that. So this is 250. It's going to be equal to 0.48. This is over 1. Cross multiply that. We see that X is essentially 0.48 times 250. And then this gives us 120. Now what are these situations? That's people, right? That's persons. At this point it's given as persons. Okay, done. Now that we have this, and then our job is to then what? Oh, the question says, is the choice of choosing a juice independent of choosing a sandwich? Can you see? This is the question of independence. So what do we know? We will then find out. So we already know now that, well, we know that the probability of taking a juice and a sandwich is already 0.48. Now we want to find out what is the probability of doing a juice multiplied by the probability of eating a sandwich. So this is equal to, now taking a juice, oh, by the way, we got this as 120, so we need to complete this. 120 plus 30, this is 150. Now if this is 150, this is supposed to be 100, and if that's 100 minus 20, that should be 80. Again, nicely, it works out. So fill up the thing. Now the probability of taking a juice is going to be the total of taking a juice. So that's 150 over the total, which is 250, times. Now the probability of taking a sandwich, now sandwiches, there's the total is 200. So it's going to be 200 divided by the grand total. We always divide by the grand total. So let's see what that is. 150 over 250 times 200 over 250. So this gives us a 0.48. So what do we know? We can say therefore the P of J intersect S is indeed equal to the P of J times the P of S. If this is the case, we can say therefore choosing a juice right, is independent of choosing a sandwich. Always answer the question as it is asked, okay? Don't answer your own things, okay? Answer what is the one, okay? So this is a conclusion that this is independent events. Why? Because we saw that the left-hand side here equaled the right-hand side of our product rule. So we literally had to prove that true. So as you can see, usually, with the contingency table, it's either going to do some individual probabilities or combinations of, but sometimes you may be asked to do the unions. So remember, the rules still apply no matter what tool you have, but there are certain rules that apply better in a certain type of a tool for a given type of a scenario. All right, guys. So this one was nice, we were given, but remember, once you've got two categories or more type of categories, be it 2 by 2 or 2 by 3, hence we say two-way contingency tables, 2 by 2, 2 by 3, things like that. But you cannot have 1 by 2 and then you're gonna do a contingency table. No, it has to be 2 by 2 or 2 by 3, 2 by 4, whatever, as long as you've got two categories. yeah I'm sure this is easy, guys. I'm not gonna go through further questions. There are other things, but now time is not so good. Right, so I will leave the space again for one to write notes, because I'm gonna share this document in relation to the video. I don't know if I have the right to add the document with the questions, since I am not the one who compiled it. But if it is freely available, there shouldn't be any harm. Now, question 13 says, determine the probability of throwing at least 1 6. Ooh, hear those words, at least. Why? So at least means a union, or the word or, okay? So please, guys, know these kinds of things. At least. It's either that or more. Okay, just a minute. All right, guys, so let's get to this business. So this thing says we need to calculate the probability of throwing at least 1 6 in 4 rows, right? And of a regular what? Right. So folks, now you wonder, how am I going to answer this question? This question is crazy. Very crazy. Again, we go back. Tools. So obviously, if we take this thing and say, okay, the tree diagram is going to be this, either a 6, maybe 5, 4, 3, 2, 1. Can you see it's going to be horrible? Because again, we're doing 4 times. So we're going to have again this, that, and that. Can you see it becomes very difficult to do the others? There's cluttering. So we need to be smart about business, you see. Yes, we know what to do, but now this one doesn't allow us to really do it raw like that. So now we can say, okay, how about we say we get a 6, at least a 6, or we get the others. So we can say maybe getting a 6 is a yes, and then not getting a 6 is a no, because again here, it's either we get a 6, because this thing is all about a 6. Ne? So it's either we get a 6 or we don't. So then no, maybe let's say n. It's all the others. And then we can say we throw it again. So when we do that, we either get again a 6 or we don't. And of course, even here, when we throw again, we either get a 6 or we don't. Right. Maybe let me move this one a bit down to accommodate the next throw. Maybe let's move this one too as well up so that we can accommodate the others. All right, so this again, if we throw the third time, we can get stuff like that. It can either be a yes or a no. Yes or no. It can be a yes or a no. Again, this can be a yes or a no. Can you see, even when we simplify, it still looks horrible. Now the fourth time, I'm gonna make it smaller. Yes or a no. Yes or a no. Yes or no. Yes or no. Yes or no. As you can see, this one is getting a little bit nasty. Yes or no. Yes or no. Yes or no. Okay, so as you can see, the tree diagram is horrible despite an attempt to simplify it. But now the question is saying, what is the probability of getting at least one? At least one. Now, this word also, guys, is a complement of no 6 at all. Right? Meaning it's either a 6 is there and all possibilities considered, or there's nothing at all. So that word, at least think of it as a complement of nothing at all of the sort that is described, because now we can see to do this thing is going to be horrible. So basically the probability of at least throwing a 6 is going to be all of these branches up until here, because we've got a yes there. But do you see the complement to this is a complete no? So our job here is to utilize this no to our effect, okay, as a means to an end. So this again is saying, okay, all right, okay, we can see there with all these others which are complicated, which are going to mess up our heads, those things have at least 1 6 in them. Others have more. But all of those branches that we follow them, we will see that there is at least a 6 because of the y. But there's also one that doesn't have. So those two things are complements of each other. See? Complementary events. Using a tree diagram. Now, let's say out of these, if we're saying a yes here, this is basically obviously 1 out of 6. Right? So throwing a die again, it's still going to be 1 out of 6, but I'm not going to focus on those others. But we want the no part. Now it's going to be all the other 5 out of 6. Again, these are independent themselves. So this is good. 5 out of 6. 5 out of 6. Now I'm focusing on the no. So can you see, understanding the question, understanding what you can do, again, the tree diagram will give you an idea of what is needed here. So we can say, okay, well, we understand that the probability of obtaining a 6, that's a yes. Right? Right. Or, wait. Whew. This one is saying at least 1 6. Okay. Maybe let's just write it as it is given. So we can say the probability of at least, because this is what we write here, probability of at least 6. which is at least y, or 1y. Let's say at least 1y, which represents a 6 here, is going to be, or so we can say here this is going to be plus the probability of no 6 at all, no y, or we can even write n in this case. Maybe let's just say no y, or y prime, whatever. No y at all. This is going to be 1. I don't know, guys, sometimes this thing gets overwhelming. So this is what we want, p of at least 1y. See, this was meant to be 1. Goodness, I said on y. So this is 1y. So 1y is going to be 1 minus the complement of that situation. So I'm going to move on, say, therefore the probability of at least 1, yes, it's going to be 1 minus. Now these probabilities, we multiply them, right? So this is this number multiplied by itself. How many times? 1, 2, 3, 4. So this is going to be just 5 over 6 squared. To the exponent 4, sorry. So this is going to give us the answer. Can you see, guys, sometimes when the question is silly, you try and simplify the question for yourself, and the only way you will do this effectively is if you know what to do. So we're getting here a 671 over 1296. Of course, percentage wise, one can say this is 51.77%. I think it's nicer, this one, to simplify into a decimal or a what, or a what, or we can say this is basically 0.5177 to at least 2 decimal places. So we can stop there. Again, because this is ugly, of course, guys, try to look at the stuff that you have. This doesn't look nice. It's too complex. Wouldn't make sense to someone immediately when they look at it. But 51% is easy to gauge where this is. That decimal as well, it's easy to gauge this is. It's almost around 0.5, which is closer to 50%. So folks, yeah, 4 hours of doing this thing. Again, guys, there's no excuse. As you can see, we had to use complementary events while using independent events in the mix. So yeah, bafethu kunjalo. Because the independence here is not between a yes and a no, but the independence is on the node to the next node to the next node. As you can see, this is the same thing repeating itself. So that spells out independence there. So can you see it's a portion of this? So again, if you wanted to use this, you would have to go through this problem right here, because it's either that, either this, that. So you're gonna have to add all those things up, and that would take you a country mile, and maybe it would take a whole week to solve. And remember, in the exam you only have perhaps 2 minutes to solve that problem. Now, knowing how to construct the structure there, which already gives you an indication of what is best to do here, that you can do in 20 seconds. Then after that, you study this for the next 20 seconds, and by the end of the minute you've already constructed the rule which is best to use. By the next minute you've arrived at the answer and you're moving on. Okay, great. Now number 14. Okay, so question 14, I'm gonna try now to move because guys we've got quite a few. Okay, that's it. Okay, we only have 2 more. Okay, we can take a bit of momentum. Again guys, this is a course, so we're trying to get you everything in its best format. As you can see, the two-way contingency table is not so common, but remember, know how to do it, know how to spot when it is necessary. Practice those questions in your textbooks. But you will see most of the textbooks and study guides, they often volunteer the contingency table, but you would have to fill it up and answer questions. But remember, in this next exam, you may have to construct it. Remember, what has not been asked the most is likely to come to bite you. What has been asked the most is likely to horribly embarrass you for not knowing it. So there's no excuses you can put forward. Anyway, guys, this is June 2023. Okay, again, if you are a person who watches my channel, you will know that I've done a video of that question paper. And that question on probability is part and parcel of those. But for those who are bumping onto this for the first time, they don't really know my channel, so probably this will be the first time you see this. And that's if also you haven't looked at that question paper, which would be a crime for a matriculant. Because remember, guys, you've got to know the recent papers that surround the time in which you're going to be sitting for exams. You also need to know the recent past, I would say, which is the past that surrounds the recent papers that you've seen. Once that is sorted, I promise you, there's no way you wouldn't be ready for the exam, because the idea is not to cram. The idea is to understand. Your understanding would be enough at that time. And remember, the exam that you're going to be brought is going to be around those ideas. Yes, they can bring a question in the very remote past, but trust me, it will have something to do with the questions in the recent past that you've done. So it's your job to really be an all-rounder. If you're playing cricket, you should be able to bowl and bat. This is how maths is supposed to be. You can't just be a mathematics student who doesn't know how to bowl and bat. Maths needs all-rounders. If you're not an all-rounder, you'll always get partial success, and that is not good. Anyhow, let's get to the business. 3 events, A, B, and C. Imagine 3 of them. We know a tree diagram can be used. We know a Venn diagram can be used. Right? Are considered. Now we see P of A, good. P of B, good. There's a separate set. Then P of A or B, that's the union. So that's good. So if we've got this situation where there's a union, there's these individual sets essentially proper. It says now, are the events are events A and B mutually exclusive? Well, that's a very good question. Are these mutually exclusive? Meaning the intersection between them, if at all we are to consider it, it means basically, is P of A intersect B equal to 0? This is what the question is asking. Because for them to be mutually exclusive, that's the idea. All right. So are they mutually exclusive? Of course, we don't know at this point, so we might just find out. But now let's have a look and see. Okay. Now, of course, we don't know about A and B in terms of the scenario. And if we skim the others, we see that determine the probability of only C if it is further given. So now that's going to start to modify this. But for the first instance, we can say, okay, let's get our tool ready. Our tool, we've got A and B. So we don't know whether these ones are sitting together like this or not. We don't know. So this is more of what you would do on your rough work, because you can't present something you are not certain about as part of your answers. Because what do you do with the uncertainty? It's gonna hurt, right? Okay, let B is not in the right place. I don't like it. So there it is. So we are a bit uncertain. So this would be RW at this stage. Okay? It should be in the rough work, because this is half-cooked meat. We can't dish it to the people. Now we find out. So the only way to find out here is to use our product rule. Addition rule. We don't have a choice. Can you see the interplay between this? Sometimes you don't have the tool complete, but the rule can assist given the information. So we know that P of A or B, because this is in general, is always equal to P of A plus P of B minus P of A intersect B. And we know our interest is to uncover what is the value of P of A and B. So now we got P of A or B is 13 over 20. This is equal to P of A is 2 over 5. Then P of B is a quarter. So minus P of A intersect B. So I'm going to go for the jugular. So the probability of A intersect B is equal to. Now let's see, what is the sum of 2 over 5? 2 over 5 plus a quarter. As a quarter, that gives us 13 over 20. So if we transpose that, it goes to 0. So this is 0. Now indeed, we know that it is so. And if this is the case, we can say therefore A and B are mutually exclusive. Ne? You know. They are mutually exclusive. Right. Now the question is, if they are mutually exclusive, are they then complements of each other? Not necessarily. So be very careful. Complements have two rules. First, they must be mutually exclusive. Second, their probabilities must add to 1. As you can see, the probabilities of A and B individually don't add up to 1. So they are not complementary events, but they can still be mutually exclusive. So remember that. So let's talk about this one. So they are definitely mutually exclusive, but I want you to note this thing I just said, because this could be the question if this thing is repeated. Note, probability of A plus probability of B is equal to 13 over 20, which is not 1. So what do we say? We can say therefore A and B are not complementary events. Okay. All right, okay. So guys, I wanted to say this because I know these things will lead to a lot of confusions if not clarified. This is why I'm taking time, because I know a course, guys, needs to be effective, not necessarily efficient. That means there has to be a cost to this. Time, guys. Look, this is for free. I'm giving this for free. I'm not getting a cent for doing this. So you guys, I know, kunale tendency ke bantwaneni besikolo. When something is for free, people think there's no effort put in that. They all automatically think this is just work. It's gonna waste their time. This is why, guys, you'll never win in this world if that's your attitude. Because in the real world, folks, I can tell you, you know, the most important things are freely available. Think of the oxygen you breathe. Do you pay a cent for it? Hell no. Right? But would you live without oxygen? Hell no. So here's the thing. Free things are the most important. The things that are paid for, it will depend on how careful are you with your selection. And of course, what is the purpose for that selection? If the purpose is not aligned with what you're going to purchase or what you're going to get, then it's a complete waste of time and money. But if you've carefully selected exactly what you're looking for and you are going to pay the price for it, you just might benefit. Or it may not change anything, while it does not make you lose anything either. But free things, folks, oh, they are very useful because this is what is often overlooked. So, of course, guys, we are winning, right? So, these are not complementary events. Please, not complementary. Purely because the probabilities of A plus the probability of B is not equal to 1. Sometimes you may be asked that question as well. I can say, perhaps, are the events mutually exclusive? The answer may be, yes, they are. Then it may say, comment on whether these are complementary events or not as well. Because we saw that in the rule, we knew that for things to be complementary, they have to first be mutually exclusive. But there's an added thing. Their probabilities must add up to 1. Yeah. Now, you've got it. Ne? Yes. Hi guys. If I never understand the probability, so that you can understand it. Even grade 11s, guys, please watch these videos. I'm actually gonna tag it grade 11 and 12. And it's up to you what you do with it. Okay, guys, let's not talk now. We've answered the question. Next one. 14.2 says, determine probability of C only if it is further given that P of A or C, can you see that's the union, is 7/10, and P of A and C, that's the intersection, then we've got 2/5. And 2P, 2 times the probability of B and C, can you see there's an intersection between B and C, is equal to the P of A and C. Okay, great. Now if we go back, we can add the third one. In fact, here we decomplex these two because they are mutually exclusive. So it means B is seated over there alone next to this. What happened? And then we've got a C now, which intersects both. Right. Let me do it a bit better. Right, so we've got C now. That was B. And we can see A and B are mutually exclusive, so it gave it to us. Now, once you understand what is cooking, you can put it there, but again, it may still be rough work, because remember, you don't necessarily have to show the tools, but you use the tools to help you do these things. But remember, the instruction almost always dictates so that if you use the diagram, a graph, a sketch, whatever, we actually would love to see it, because we don't want people who copy. Ne? Because when you show everything, it eliminates doubt. Okay, enough stories now. Now we have this situation, okay, that we are given. Nice and easy. Right. So we don't know about the sample space. We don't know about what is outside. So magnifier when. So here we can at this point put an X, because we don't know. Are they all exhaustive or not? We don't know. We will find out. But folks, we are told that A and C is 2 over 5. So this is 2 over 5. And we are told, okay, the P of A or C is quite a big one now. It's that the union of those two. It's big. It's 7 over 10. That includes a portion of B. We're not interested. But here's the thing we can see is that 2 times the probability of B and C is equal to the probability of A and C. So what does that tell us? It tells us that the probability of B and C is going to be half the probability of A and C. So that one is half of 2 over 5. So this is the rule that helps us to work the probability of B and C. So this one is going to be basically 2 over 10, which is just a half, isn't it? Yes. Yes, of course. Yes, of course. Yes, of course. So we know that the probability of B and C is going to be a half now. We're winning. But again, this is rough work, guys. Remember, you don't really need to present this, because you know what, it's not complete, so we cannot really say much, but it helps you to structure your thought process here before you run into the hot waters. Now we can see that to find C only, which is this one, this is our question, we first need the probability of C as a whole. You get it? Because once you get the probability of C as a whole, we simply take out the intersections and then we win. You know? So that's what we need to do. Okay. But again, I think we need that probability of A and C. You get it? Of course, okay, we've got A or C, A and C, and we've got A. So we don't need this rule as yet, but perhaps we need it for the other stuff. So we can say, okay, probability, no man, I win, man, you win. So we know that the probability of A or C is going to be equal to the probability of A plus probability of C minus probability of A and C. Right? The addition rule does not discriminate. So this implies this is 7 over 10. We've got that it is 2 over 5 from above. Now our job is to find the probability of C minus the intersection of A and C was given as well as 2 over 5. Right. And as you can see, the intersection already has 2 over 5. So it means there's no A only. So anything that is in A also belongs in C. Otherwise, there's nothing that belongs in A alone. So A, very strange question here. So of course, guys, we go for the jugular. Probability of C here is, so it's going to be 7 over 10 minus the sum of 2 over 5, or the difference of 2 over 5 and 2 over 5. Wow, that's 0. Are you kidding me? Are you kidding me? Hey, when? Hey. Oh, because there's nothing else in A only. Okay. Wow. Therefore, this is 2 over 5 as well. So that means C as a whole is 2 over 5. Okay. Very interesting stuff. No. Lying. 7 over 10. So P of C is going to be 7 over 10 in essence. Right. So this is what we have, okay? 70%. Now we've got a story to tell that, but because we need to sort out some things, we know that, but we were told that 2 times the probability of B and C is equal to the probability of A and C, isn't it? So we want this probability. We want that to then work out the rest, because we know that from this probability we need to cancel the intersections with the others, then it will leave us C only. So that's why we need that probability of B and C. Is going to be probability, in fact let's just say half, times the probability of A and C. Okay, so this therefore, okay, maybe this implies that the probability of B and C is going to be a half of, now that of A and C we were given that this is 2 over 5, which we can say this is equal to basically a half, ne? So this is 0.5, this is a half. So B and C is a half, as we can show it there. We can say then the probability of C only is going to be equal to the entire probability of C, 7 over 10, minus the half plus the other intersection, which was 2 over 5. Right? Right. So this would give us C only. Now I'm forced, because of space, to do what I don't really recommend, stacking the equal signs. It's not palatable. Minus 0.5 plus 2 over 5. Then we get, hi man, couldn't the answer yaba wrong on Goku. Now I'm not happy because my answer is not quite correct. Dang. Yeah, man, this is wrong. This is 1/5. Oh Lord. Yes. How did I do this calculation wrong? You see, sometimes this is 1/5. Actually, it's 1/5, not a half. Okay, apologies there. Of course, the calculation will always tell when there's some mistake, guys. So this is why sometimes trying to do things right is always the best thing. Okay, let's do it again. So that is 1/5. So this is 1 over 5. Whereas the answer gave us a negative answer, so we get a 1 over 10. Now that is 10% or 0.1 or whatever. Okay guys, I'm a bit tired and hungry. This has been forever. But again, if you want to learn, this I think is nicely aligned. So congratulations to the one Who compiled these questions? Can you see they helped me to teach you something nicely? And by the way, I don't have the official answers to most of these questions except the past exam question papers that you see there indicated, because you can find those. The other questions, it's just the understanding, so please double check those and make sure they are correct, because I may have made a mistake. So we know now that probability of C only right here is 1/10. Okay. And C as a whole is basically 7/10. Ne? Yeah. Because if you see A and C, it's literally the entirety of C, because there's 0 A only. So you see, that makes sense. Okay, now we are good here. So please guys know the rules. Sometimes we may be given some local rule like this one that helped us to find the intersection of B and C, which was necessary for us to then calculate that C only. So these are one of those questions that, yep, 14.3. Says determine the probability that events A, B, or C do not take place. Can you see? So this is suggesting we need to find X. We need to find X. Now, what did we say? We found A and B, but the probability of B is a quarter. So if we've got 1/5, so this is going to be a quarter minus 1/5, right? It gives us 1/20. So now this is 1/20. So now our stuff is done. Now remember, not these happening and them happening, those are mutually exclusive, are they not? Because it's either they happen or they don't happen at all. So we're going to use complementary events. Yo. So we just want the complement. So X is a complement. So it's going to be equal to 1 minus the probability of A plus the probability of, okay, maybe let's put it this way, of A or B or C. Yeah. Okay, guys, I'm a bit slow now. Tiredness has crept in. So what did we just use there? We know that X is a complement of A, B, or C not happening. So you see guys, asoze uphinde ifumane ivideo sana ezakubeka emcimbini ubegqitha le. Hayi mhlambi sezeza in the future, but okwangoku angiqondi bikhona. So guys, you need to know these things. Ne? Okay, let's not worry about that even. It's crazy, man. I don't know why I had to say such a thing. Forgive me for those who are very fragile. They will feel offended from this, but again, I'm being silly to say fragile, but it's obnoxious of me to say that. Right. Now, bafethu ufuna ulala futhi mina. And le moto abayiqheli ngoku. Ndifuna nokubuyela umva bafethu. Otherwise into ezininzi zizomosheka if I don't make it back. Anyway, let's see. I hate what's gonna happen if they don't give me this car today. I really hate what's gonna go down. It's not nice what's gonna go down. You know. It's really not nice what's gonna happen. I just pray they give me. Because I would not wish for what's gonna happen tomorrow. But Sani. khona ezinye izinto nje ezaba inkinga nyana. Okay, determine the probability. Okay, now we saw what we're gonna do, right? So we can say, well, okay, let P of P of A or B or C not happening like that, B equal to X. Ne? But again, we can write it like that, you know. Let's put it this way. Let's not let anything, let's go for it. So probability of A or B or C prime, like that. It's going to be 1 minus the probability of A or B or C, literally. These are complementary events. This is 1 minus. Now we just do everything. See, all those probabilities that we see, we add them up. So we saw that C as a whole, which includes A, is going to be just 7. Okay, let's just do it nicely so that you can appreciate that this is 1 over 10 plus 2 over 5 plus 1/5 plus 1/20th. Here's what it says here. It's 1 over 10, 2 over 5, 1 over 5, and 1 over 20. So let's get it. So this is 1 minus 1/10 plus 2/5 plus 1/5 plus 1/20th. So we get a quarter. Again, the answer is a proper fraction, which is proper. We can accept it. So it means our X here is nothing but a quarter. Giddy quarter. Anyway, guys, so can you see sometimes how questions can be so packed? And you can learn so much from these questions if you do pay attention to what you have and what it means and what you can do about it. Enough is said, so I'm going to leave this space again for one to write their notes if they want. Let's look at question 15. Okay, I'm a bit tired now. Yeah, it says now there are 10 boys in a class of boys and girls. So how many boys? 10. So we can let the number of girls be X, right? Whenever it's not given, that's what we do. If 2 learners are selected at random, now 2 learners. Now we don't know. Do we select one after the other? We just say, hey, you 2, get here. I don't know. Selected at random, then the probability that both are boys is 0.15. So obviously it means we choose one first and then the second one. Otherwise, if we just grab both and then what are the chances that they are boys? That's silly, né? So I would suppose they should tell us nicely that we're choosing 2 people, one after the other. Now that would make sense, okay? So sometimes there's not so much skill in the okay, let's not go there. I'm gonna start saying wrong things and this is not my work. Good. So it says how many girls are in this class. So what can we do, guys? We've got 2 categories, boys and girls. And you know, these are independent. In essence, now this is now the natural situation here. It has nothing to do with other things. Naturally, boys and girls can coexist, and a boy being present and a girl being present is independent of the other one. But in this class, they are there as part of the set. Now, when we pick one and we don't replace the other back, so this affects, because we're not going to pick one student and record their gender and put them back and then get the other one and record their gender. So we're going to pull one. Then that means the total is going to decrease, right? And then when you pull the next one again, it's a different story. So this means these are essentially not independent events, meaning getting the girl over a boy. Although being a girl and a boy in this scenario is two independent events, but we have literally created not independent events. Now, once you see this, what does it mean? A tree diagram would be our good friend here. So let's do it. So we pull one student and the other. So the first one can either be a boy or a girl. When you pull the second student can either be a boy or a girl. Okay, again here the second student, the second time around could either be a boy or still be a girl. So those are the possibilities. Now, this is good. Oh, by the way, we will say let x equal to the number of girls in the class. Okay. So now to pick a boy is going to be 10 over 10 plus x in total. Then to pick a second boy is going to be 9 because I already picked 1. And 10 minus 1 is also going to be 9 plus x, isn't it? That's what we're going to have. Then to pick a girl under these circumstances is just going to be x over 9, isn't it? Yeah, 9 plus x, sorry. Yeah. So that's like it. Now to choose a girl is going to be x over 10 plus x. To choose a boy is going to be 10 over, we've taken 1, it's going to be 9 plus x. To take a girl again is going to be x minus 1 over 9 plus x. Okay, so this is essentially what we do again, guys. So these are higher grade questions again that essentially force a student to insert a variable, do a proper thing on the tree diagrams, and then solve the problem. So obviously we were told something that the probability that these students are both boys is 0.15. So now this means this arm is what we are talking about. So this is the arm whose probability we are given. And we can see that within this we will have x as the variable, and x is the number of girls, so we need to solve for x. So we were told that the probability that we've got boys like SUA is 0.15. Now we simply multiply here. This is 10 over 10 plus x multiplied by 9 over 9 plus x equals 0.15 is 15 over 100. Is it 15 over 100? Yeah. 2 after the decimal. That's the story. Okay. So now we move on. Now 10 by 9, that's 90, divided by 10 times 9, that's 90. 10x plus 9x, that's 19x. Plus x squared is equal to 15 over 100. And then we cross multiply. Again, we don't need to show this. This implies that we're gonna get 100 times 90. 9 scored. 9 scored. Okay, maybe let's start with the x's. It's gonna be 15x squared plus 15 times 19. That is 285x plus now 90 times 15. This is gonna be 1350 equals 9 scored. Ne? Yeah. So we then see we have ourselves a quadratic. So 15x squared plus 285x This is certainly going to be negative. So we say 9,000 minus 1350. So this gives us minus 7650 equal to 0. Now we can divide by 15, get x squared plus. So we say 285 divided by 15. It's going to be 19x minus, say, 7650 divided by 15. We get 510. Not so bad, right? Right, so let's see. Are we able to do the things? I'm thinking. Let's say 510 shift fact. So 510 is 2 times 3 times 5 times 17. Okay, we're going to be subtracting. So let's say 17 by 2. 17 times 2, that's 34. Minus 15, it's 19. Good. So this is great. So we know that we're going to take 17 and multiply to 2 in these ones. So yeah, it gives us the answer. Right, so we get 34 here. And we get 15. So 34 minus 15 is 19. So it's good. So we can factorize. So again, guys, depends on your taste for factorization. So the positive one must be the bigger one, right? Should be 38, 34 when not. And then the smaller one should be 15. Now this is nicely factorized. Again, x here should be a whole number, not a negative integer. So in this case, we know that x is going to be 15 girls. Done. All right, so guys, there's nothing that would cement this idea better than this question. So I hope you folks can see how things work here. You can think of other questions you could ask under this situation. As you could see, the tool became very useful for us to solve the problem. Otherwise, it would not be so easy. And we still remember our algebra. So one cannot say, ayenzeki lento. No, iyenzeka. Okay, guys. Now let's do the last question and end this thing, because this is the last. We will do the counting principles next on a separate video. Okay, so let's first handle these ones. All right, question 16. What is cooking there? A bag contains P red marbles and Q blue marbles. Okay, so the sample space here, the number of marbles in the sample is going to be P plus Q. Right, so this is now a true higher grade question again, because it's hypothetical stuff. So one marble is selected and its color is noted. The marble is returned. So if we return it, what do we mean? We're gonna have independent events of some sort now to the bag, okay? Along with, see this? Along with n other marbles of the same color as the one that was selected. So this means, folks, out of this total, if we select, say, one red marble, right? Whoa, what is this now? So this means if we selected one red marble, what was going to be left of the red marbles? It was going to be the P minus 1, isn't it? So P minus 1 is then denoted as N. So this is equal to N. Right. Right. That's the story. Because that N says N are the marbles of the same color. This is when we have taken one out. What remains, we say it's N, but in this scenario, it's going to come up as P minus 1. So we're saying P minus 1 is N, right? And again, if we take one blue, we're going to have basically Q minus 1. And again, we are saying this is equal to N. So this is, again, a very silly situation here. So where N is literally not discriminatory, it's whatever remains when we pick one. So it says now a second marble is now selected from the bag. Prove that the probability that the second marble is red is not dependent on the value of N. Okay? So this says prove that the second marble is red is not dependent on the value of N. And now what is the value of N in terms of the red is basically P minus 1. So that would be the idea. So P minus 1 is equal to N, or N is equal to P minus 1. So what do we do here, guys? Well, we will do what we know best. So tree diagram, guys. So as you can see, tree diagrams have a tendency to come up more than the others. So be comfortable doing this. So we've got either a red marble or a blue marble, right? Then when we do the second pick, again, just a moment. Okay, guys, so that's gonna be red, that's gonna be blue, and that could also be red or blue. Okay, I'm just getting the information that my car is not. Of course, they asked me if I could wait. So now to avoid them rushing things, I said let me just finish. So I'm probably gonna get it in the morning. If I get it before 10 a.m., that would be good. Or even after 10, but say around 1. That should be okay because it won't affect so much of what I need to do. Yeah, it won't. I will try myself to make sure it doesn't. Anyway, guys, this is good news because if they can finish by tomorrow, say noon, then I'm good. It won't really kill me. But if they can't, whoa, I'm gonna be dead. But as long as I'll be able to leave tomorrow is good news. Okay, guys, let's not talk about my issues. Let's talk about this one. Technically, essentially, zizo zinjalo zizonke ziphelele. Yes, this is going to be P must be red ones divided by the total, which is P plus Q. Now, remember we returned it, so it means it's going to be again P divided by P plus Q must is like this when we take the second one. B ones is going to be Q not A divided by P plus Q. Same things there is going to be Q divided by B plus this is B divided by B plus Q. Same things, this is going to be B. No, this is going to be Q divided by P plus Q. Right. So again, please know how to do these things, folks, and make sure it's done well. Okay. So now we are saying the probability that the second ball is red is not Now we're saying the second ball must be red. We don't care how it started, but the second one must be red. So this means it's either this situation or this situation. Can you see? Our tools give us the right direction. that for the second one to be red, we don't care about the first one. The first one could be blue, first one could be red, but the second one must be Roy, man. Roy. All right. Anyway, this is the last one. So guys, let's get the business. So it says we need to prove that the probability that this is the case is not dependent on the value of n. Right. So here we can say, I don't know what to say, guys. We can say note n is either p minus 1 or n is going to be q minus 1. I don't know if we can say nb, or we can say, given the scenario, this is the implication. Sometimes certain things are crazy, but I think it is worth mentioning that, because if we don't, we need to be good, because we're talking about n here. So let's see, we're saying the probability that the second ball is red, so meaning it's either R, or it's gonna be BR. Right, this is gonna be equal to P over P plus Q times P over P plus Q plus, this one is either Q over P plus Q times P over P plus Q, because we returned the thing before we got to the other one. So this is complex. I don't really want to write that. This is P squared over, this is basically P plus Q squared, okay? Plus, this is going to be QP. Which one comes first? P. It's going to be PQ over P plus Q squared. Same denominator. So this is P plus Q squared. Now there we've got okay, we can take out the highest common factor, which is P. We will end up with P plus Q, okay? Yeah. As I see, like, okay, let's not rush it in case you guys are not going to follow. So this one is going to be P squared plus PQ, right? Then we can factorize the numerator, taking out the highest common factor. We end up with P plus Q divided by P plus Q all squared. Can you see these brackets are the same? The other one is squared, so it means this bracket will take the square. So we end up with P over P plus Q. So that's the probability that the second ball is red. So we know that P of RR or P of BR is like that. And what do we see? Can you see this is P over P plus Q? There's no N here. So this is indeed independent. So we can say therefore P of RR or BR is not dependent on N, which is equal to P minus 1. There's no P minus 1 there. So I don't know, guys. Sometimes these questions are crazy, but perhaps I'm missing the point. It's possible. Please confirm with your tutors, your teachers, your peers, if this is the best way we can answer this question. As I said, I don't have access to the solutions to this according to the persons who compiled the question. But at the end of the day, we've answered the question using our rules and understanding the utility of the tools, because once we've got the tools, we will see what we can do. So in this case, we can say indeed is not dependent on n, because if we can define what n is, which we've shown in this case, the second ball being red, we can see there's nothing about p minus 1. So it means it does not depend on it at all. It does not depend on it at all. All right. So guys, again, this was just an algebraic spree, the last one. Again, a higher grade question that is there to shake things up a bit. So guys, this would be the end of our video for our probability course for grade 11s and 10s. Sorry, grade 11s and 12s. I hope this is going to be good. So we're going to do another course on counting principles, because I would rather we treat that separately. As you could see, there is a lot to, there is a lot to know already on the grade 11 work, because it includes all the work from the previous grades to grade 11. And of course, we're asking questions at the level of grade 12 as well, like these higher grade questions. That is what a grade 12 can be asked. But it doesn't mean a grade 11 may not be asked, but they're not likely to show up in grade 11 type of questions. They're quite advanced. And yeah, guys, 5 hours of this, so you can cry about it, you may not, but hopefully you learn. That's the very least you can do here. At least learn something. But crying does not pay, bafethu. Nenkamela iyakhala. Kodwa abantu abayeke ukuyilayisha imithwalo enzima noba ingakhala kangakanani. So ililingabethwanga for nothing, because okusalayo izawuthwalisa ubunzima iphinde iqatyelwe ngaphezulu. So ukulila ke bafethu nakungithusi, so manikhala bafethu ngiyanilaha ngivele nginilahe straight into BS. Okay guys, I hope this is nice and clear. I try to write in the best way I can, knowing my writing is horrible, and I try to be as explicit as possible and to demonstrate as much as possible, so that folks, there is no confusions left. So this is the end of our document and the end of this video. So if guys you hate it, please give it a like. Do the opposite of how you feel if you hate it, but if you love it, please also confirm that with a like. So that those who may like it eventually can get to see it. Don't hide it from them. Even if you feel it's ridiculous, just expose how ridiculous I am, by making it available to your friends, because guess what? 1 person out of 20 is going to get it. And that person may have never had an opportunity anyway to get it. This might just be their only absolution. Think of those people. Don't worry about yourself if you're already high flying or you don't find this relevant at all, but just think of those who may find it relevant, so that at least they can benefit. Because you never know. You see, the person you think you don't care about today might be your husband if you're a woman. Okay, a girl. Because people are school going and mostly girls. But again, you may find that you're a woman who's upgrading, That might be your husband, you see. Trust me. And you want a husband who's functional, who's effective and efficient. This might just be the way to getting those people into that level. So you're helping yourself indirectly. That person might be a teacher to your child. And if that person gets to understand this properly, they might just get your child in shape, That person might be a doctor to your mother, who you love so much and you want to survive any disease that comes along. That person may only have this one shot through this video to elevate themselves enough to qualify for medicine, when they combine their final mark at the end of the year. That person might just be the only person who could cure your mother. The rest, however best rated they are, they may not see a damn thing and say there's nothing they can do. What if that person is the only one who can do something about it, and successfully so? You never know, guys. That person might be, your supervisor tomorrow. You don't know that. And if that person is clear, because that person may just be your supervisor because they were parachuted into the position, but they don't understand the work properly. Maybe this video might just make them understand most of the things. Maybe it can actually stimulate them to force themselves into understanding. When that person is your supervisor, they may just give you a promotion because now they understand your potential better, because they are not ashamed. Because remember, a supervisor was not ashamed of their junior's brilliance. They don't pretend. They can even recommend you for their very own position tomorrow, because they know you're good enough. Because look, people who understand things are not intimidated by those who are bright, who are still upcoming. But those who are not so good, they make sure they suppress everyone until they have had, that position long enough to then say, okay, now I'm old, tired. But until then, they will make sure nobody gets that position. And that's the sad thing that we see across the board. But hey, you never know, that person might just be the one, So guys, that person might just be a partner, a worthy partner in cooperation, If you are doing business, that person might just do something that may actually elevate your business or even your partnership together as partners in business. So don't be selfish, folks, and think just that you don't know that person today, that person doesn't exist. What is important to you in the future is not known to you at all today. So try to not close the circles, make them bigger instead. Anyway, guys, goodbye. I'll see you on the next video when we handle the accounting principles, because they themselves come with their own issues. Okay, so we got to dance with that and hope that you will understand it.